Hi everybody, welcome, super duper welcome to this amazing session which was highly demanded, highly awaited, and that is none other than the PYQ Marathon. So as the name suggests, this is going to be a marathon session. I'll be discussing with you tons and tons of beautiful, mind-boggling PYQs, and some of them are even not going to be PYQs. That is the secret. So please keep your pens and notebooks ready. We are going to dive into the session straight away without any further delay. You know the drill. I have tried to capture all the questions which actually are important from your upcoming JEE Main January attempt. What I mean by that is the different types of questions which can be asked covered. All the most important concepts, results, formulas covered. The multi-conceptuality of questions, which is super famous in JEE Main, covered. If there are questions which can be solved by alternate approaches using a trick or a shorter method, any time-saving hack, covered. So everything is covered. This is a marathon consisting of super rich variety of questions. And trust me, people, if you attend the session from start to finish, and because this is a series, I would love for you to attend all the sessions which are designed in this series. If you do so, diligently, sincerely, with focus, with your complete attention and honesty, this is actually a game changer. It's going to level up your prep 100%. It will guarantee that 9-10 percentile which you are wishing to crack in your mathematics in your upcoming JEE Main January attempt, right? It seems tough, it won't be. After this marathon gets done, you will realize how much confidence has been boosted inside you with regard to your preparation. So everyone, give me a quick start. Give me some fire emojis in the chat. Give me some smileys in the chat. Give me some josh, some enthusiasm in the chat, because this is something which you asked for and your wish is my command. So I am here for that, for you, with all the questions. All right, so let's go, everybody. You said we don't want topic-wise questions, we want complete syllabus questions. So here we are. The first question on your screen, people, the marathon in every session, whatever sessions are going to be conducted, the marathons are going to be consisting of questions from across syllabus. So you are going to be tested a lot on remembering different concepts from different chapters at multiple times. So you have to train your brain, build up that stamina, that patience, that toughness, which will get built as you go through the marathon, okay? And that will immensely help you and give you an edge in the competition on the D-Day, which is on the JEE Main exam day. All right, so without any further delay, let's get started. If you've not hit the like button, do that right away. And also subscribe to the Rankplus JEE English channel, because I know for sure that you do not want to miss this. It is going to be very important, very nice, and a very big addition to your preparation. It's going to polish your prep and make it spick and span perfecto, as I say in my language. Let's get started. Bhoomika Ma'am to your rescue, beginning with the PYQ Marathon. First session, first question. Everybody grab your pens and notebooks. Read the question. Read the question and try to make sense of the statement. Try to think which concept from which chapter is this actually hitting. What is it demanding from you? What is it demanding from you? Okay, try to visualize the setup, try to recollect the concepts, and then try to start writing. Let's go. If f of x is given to be an integral from 0 to x, 1 plus t cube raised to the power minus half dt, and g is the inverse of f, what is the value of g double dash upon g square? Do you know g is the inverse of f? This phrase, just this much phrase, is demanding a specific type of approach. Just this much phrase, if you see in any question, you have to remember what approach to apply, what concept the question is asking me to implement. What is it? Any clue? Because this much phrase is very powerful. It itself is a hint. When the question says g is the inverse of f, this question itself is giving you a big hint, very loud hint as to actually what are you supposed to do. So it seems like the question has no direction. It's not giving us an exact direction as to, okay, move in this direction and do this and do that, step 1 and step 2, step 3. That's not very clear. That seems so, but actually it's not. When the question says G is the inverse of F, it actually means F inverse is G, but a stronger statement would be FOG is identity and also GOF is identity. Making sense? This is what you have to actually interpret when the question says G is the inverse of F. Don't stop at G is equal to F inverse. Please move down to an even deeper level, which is what? Fog is identity, GOF is identity. Very, very important. Seems like, yeah, ma'am, that's obvious, I know. Yeah, you know, but you don't write it. When you don't write it, you don't use it to your advantage. That is why I'm saying whenever G is the inverse of F, you have to realize F inverse is equal to G. That's not enough. Write fog is identity, write GOF is identity. Why? Why I'm telling you? Because the trick is what? How is this phrase G of X is the inverse of F? How is this acting like such a strong, such an out loud powerful hint? How is this acting like that? You are given F of X is equal to integral 0 to X 1 plus t cube raised to the power minus half dt. Yes or no? Yes or no? Because you know that fog is identity. This means F of G of X is equal to X. Oh. If F of G of X is equal to X, I already have F of X in picture. What is the but obvious next step? What do you think is the but obvious next step? Isn't it replace X with G of X? Huh? Replace X with G of X. Isn't that the obvious step? It's valid if you do so 100%, but isn't that the obvious step? Yes, it is, because when you do so, you will have F of G of X is equal to 0 to G of X 1 plus t cube raised to the power minus half dt. Now, why do I have a big smile on my face? Because I have actually been successful to use the fact that G is the inverse of F by bringing into picture FOG of X, which I know is nothing but X. Pretty situation, right? Pretty good looking. Now it says from 0 to G of X 1 plus t cube raised to the power minus half dt. Now that you've reached here, you know what? Now that you've reached here, again, the expression which you can see right now is itself giving you a hint for the next step. It's not obvious that that step has to arrive, but this expression is demanding, it is hammering, it's playing drums that, okay, use this, use this, use this. What? Look at the limits. Look at the limits. 0 to G of X. Variable limit. What does it call for? Variable limit. What does it call for? Yes, absolutely correct. Bang on correct. Spot on correct. Newton-Leibniz rule. We are going to apply the Newton-Leibniz rule. The question nowhere said that it is based upon Newton-Leibniz rule. Right in the beginning, it didn't strike us. But as we moved ahead, as the journey proceeded, we realized right now the only savior could be Newton-Leibniz rule, because I can see the limit is G of X. One of the limits, upper limit, lower limit, right? The G of X is the upper limit. That is my variable limit. Even if out of the two limits, at least one of the limit is a variable limit, you somehow should get inclined towards using the Newton-Leibniz rule. It should strike you. It should knock the doors of your memory. It should knock very hard the doors of your memory. Newton-Leibniz rule, Newton-Leibniz rule. The moment out of the two limits, at least one is a variable limit. Now, left hand side, differentiation is 1. Right hand side, what is it? Integrand of upper limit into dash of upper limit. So 1 plus, write it carefully, G of X whole cube whole to the power minus half. 1 plus G of X whole cube whole to the power minus half into G dash X. So integrand of upper limit into dash of upper limit minus integrand of lower limit into dash of lower limit. Dash of 0 will be 0 only, so I don't need to write the minus quantity. I have what? 1 is equals to 1 upon root over 1 plus G cube into G dash. Oh, this means, okay, let me write it in an even proper fashion. You get this? Yes or no? Yes or no? Obviously, do not lose sight from what you actually want to achieve in the end. What is the destination? The destination looks like G double dash upon G square. I have G dash in picture. I don't have G double dash in picture. I have G dash in picture, but I don't have G double dash in picture. In order to move from G dash to G double dash, of course, I would wish to differentiate this one more time. This equation, I would wish to differentiate one more time, but before that, let's simplify it. It's but obvious I would want to simplify it by squaring both sides so that I can get rid of this square root sign, right? So G dash square is equals to 1 plus G cube. Now you know what to do. Because I want G double dash upon G square, I'm going to differentiate. I will get 2 times G dash G double dash is equal to 3 times G square into G dash. Yes ma'am, no ma'am? G dash cancels out. You have G double dash upon G square is equal to 3 by 2. That's the final answer. Isn't this a wonderful question? And this, minded guys, very important variety. This question is representing a very important variety. Why? Because right in the beginning, when the integral is given to you, it says 0 to x. Yes, x is also a variable limit. So it might strike you to use the Newton-Leibniz rule, but you can't use it straight away. It will take you nowhere. No, you want G double dash upon G square. You don't want f dash. So differentiating at the primary stage is of no use. It is waste of time. So what to do? What to do is something which is given by G is the inverse of f. Once your f of x has been transformed to f of g of x, which is actually x, then differentiating using the Leibniz rule, that has some value, that has some advantage. Okay, so you have to understand what is the language of the question, which part of it is actually acting like a hint for you. Exploit that and then start solving. Don't blindly start solving a question. Every part, every bit of the question is important. Which part is acting like a hint? Which part is giving you an idea of the approach? Which part is somehow laying before you a direction? Exploit that. Use that. Identify that. Is that making sense? 3 by 2 is the right answer for this question. I hope this question is absolutely clear. Hashtag HDCC everybody. Hashtag HDCC. Any doubt, any confusion till now? One question. We're down with one question. Any doubt, any confusion? No, right? Let's go then. Let's go to the next question. It says, coming from the world of complex numbers, define a sequence of complex number by z1, 0, zn plus 1 is zn square plus iota. For n greater than equal to 1, what is the argument of z 2009 plus z 1004? Very important. This is very nice. And I know people, I know complex numbers is not one of your strengths. I know complex numbers is not one of your strengths. There are many students who are scared of complex numbers, for whom complex numbers is something which is not that strong an area. They are scared to attempt questions of complex numbers. They try to leave them. But the point is, leaving any chapter completely is never ever going to help you. It's never ever going to help you. Because if you look at the trend of the questions, bache, then across chapters, or in fact across syllabus, questions are being asked in a multi-conceptual manner from across syllabus. So matrices determinant chapter, a question from MND could involve concept of complex numbers. Yeah, a question from complex numbers could involve definite integration. So anything can get mixed with anything. Right? That is why leaving a chapter completely is not going to help you. Never ever. So please don't leave anything completely. I would strongly suggest, even if it's a chapter like complex numbers, study its basics. Please get a hold of all the standard variety of questions which are asked from this chapter, like questions based upon argument, modulus, cube roots of unity, all these type of questions, no? You take a look at them from some 1 or 2 year PYQs, 2020, 2021, pretty old, or 19 and 20, 2019, 2020. Take a look at the standard or fundamental easy variety of questions which are asked from this chapter, and get a grip on them. Learn how to solve them. Okay, learn how to approach them. At least if you have a fundamental idea of all the important and most standard repeated concepts of complex numbers, you don't need to be worried about if a very tough question gets asked from complex numbers, how will I crack it? You don't need to. If a very tough question comes, then leave it, no. But if an easy question comes or one of its concepts gets used in a high weightage chapter, then though at least you should know how to crack a question. At that time, you should not feel helpless that, oh, I wish I would have studied what is argument. I wish I would have studied the properties of modulus. That thing should not be there. All right. So what does the question say? Define a sequence of complex numbers. Define a sequence of complex numbers, and I am being asked to compute the argument of Z 2009. Oh my God. This will come very late in the sequence, and Z 1004 very late in the sequence. So the trick to crack this question is what? I'm sure you would have figured out. It's to observe the pattern. That's the magical trick. When I say observe the pattern, what do I mean? See, Z1 is 0. Only one complex number is particularly known to us. If I talk about Z2, it is Z1 plus 1. So Z1 square plus iota. Z1 square means 0 square plus iota is iota. Z3, if I find out, Z3 is Z2 square plus iota. So iota square plus iota. Iota square is minus 1. So I minus 1. If I talk about Z4, it is Z3 square plus iota. So iota minus 1 whole square plus iota. Calculate, guys. So iota square plus 1 minus 2 iota plus iota. So minus 1 plus 1 cancels out. This is minus iota. Yes or no? Yes or no? Iota square plus 1 minus 2 iota plus iota. Z4 is minus iota. What about Z5? This is Z4 square plus iota. So minus iota square plus iota. What is this? Iota minus 1. Z6 is Z5 square plus iota. So iota minus 1 square plus iota. This is again iota square plus 1 minus 2 iota plus iota. Plus 1 minus 1 cancels out. You're again getting minus iota. Any pattern? Any pattern are you able to decode? Forget about Z1. Z1 is given to be 0. Z2 is I. Z3 is I minus 1. Z4 is minus I. Z5 is I minus 1. Z6 is minus I. Z7 will be I minus 1. Z8 will be minus I, and so on. So what does this mean? This means Z2n. Z2n is minus I for all n greater than or equal to 2, not 1. Because the moment you plug in n equal to 1, you get Z2 is minus I, but Z2 is not minus I. So the pattern is actually being made from Z3 onwards. The pattern is actually being made from Z3 onwards. Similarly, you can say Z2n plus 1 is equal to I minus 1 for all n greater than or equal to 2. No, 1. Okay, or if you write it as 2n minus 1, then 2. Z2n is minus I for all n greater than or equal to 2, and Z2n minus 1 is I minus 1 for all n greater than or equal to 2. You can see when you plug in n as 2, you get Z4, Z4, Z6, Z8, Z10 and so on to be equal to minus I. And when you plug in below n equal to 2, you get Z3 from Z3 onwards. Z3, all the odd lower indices. Z3, Z5, Z7, Z9 and so on are I minus 1. This was the catch, guys. This was the catch of the question. I am not lying. This question is very simple. But if you're not able to decode that I have to work on the pattern, this can be a slippery area for you. Not lying, very slippery area for you. So Z2n is minus iota, Z2n minus 1 is I minus 1. I want Z 2009 plus Z 1004. You know, as a matter of fact, Z with an odd lower index is I minus 1. I have decoded the pattern. I'm not scared of it now. Z 1004, Z with an even lower index is minus I. So this cancels out. You're left with minus 1. Minus 1 is actually equivalent to minus 1 plus 0 iota sitting on the negative real axis. What is the argument? Come on. Argument of minus 1 plus 0 iota, argument of any negative real number is what? What is it? You know, argument of any complex number lies in minus pi to pi. Minus pi open, pi closed. The answer here is pi. C is the right option. Killer question. Killer question from complex numbers. You know, as a matter of fact now that in this question, I actually did not need any core concept. Did I need? I have only and only decoded the fact that because I'm given a recursive relation type of an equation, I need to find out Z1, Z2, Z3, Z4 and so on and analyze a pattern. During the pattern analyzation, I have just used the fact that iota square is minus 1. That much I have used. And observing the pattern and writing it in the mathematical language is something which I've written here. After that, it was a cakewalk, no? 2009 odd, so write I minus 1. 1004 is even, write minus I. Bingo, you have got minus 1, and the argument of any negative real number is always pi. Cool? That's why I'm saying please don't leave a chapter completely, even if it scares you to death. Even if it scares you to death, don't leave it completely. Please study the basics and learn about the fundamental or most standard type of questions which have been repeatedly asked from the chapter. Don't be devoid of the basic understanding of any chapter. It should not be like, I just don't know this chapter. This status, no help. Got it? Okay, dokie then. Equation of the circle which touches the line x equals y. My God, beautiful question. I'm telling you, it's a beautiful question and very, very, very important. Okay, let's read. Equation of the circle which touches the line at origin and bisects the circumference of another circle. So there are two circles being talked about. Two circles. Equation of the circle which touches this line, okay, at origin means 0, 0 and bisects the circumference of another circle. Oh, okay. This is, let's say, circle 1. And this circle is, let's say, C. I want the equation of C. C1 is given to me. C1 is what? X square plus y square plus 2y minus 3 is 0. People, this question is from circles. You can clearly see that. But what I want you to realize is, are you able to imagine the picture? You're reading the statement, cool. But is there any picture being made in your head that, oh, this is what the question is talking about? This is what the question is talking about. This is what I need to do. Until and unless the picture is not made in the head, until and unless you have not imagined what the question statement is trying to say to you, you can never be able to decode the approach to solve it. Mark my words. So equation of a circle, there is a circle whose equation I don't know. It touches the line at origin. Draw it. Draw it, draw it, draw it. Okay, this is my line given to me as what? X equal to y or x minus y equal to 0. So my circle C, whose equation is unknown to me, is touching a line. This is my line, touching a line at origin. Okay, and it bisects the circumference of another circle. This C circle bisects the circumference of another circle. So there is some circle. Let me draw it in white. And this yellow circle, my circle C, is actually bisecting the circumference of this circle C1. Can you understand? C1 is the white circle. C is my yellow circle whose equation is unknown to me. My circle C is bisecting the circumference of C1. Who will tell me what is the meaning of bisecting the circumference? In this question, this much part is playing the major role. Oh yes. Many students out there don't even know the meaning of bisecting the circumference. When one circle bisects the circumference of the other circle, what do you mean? When one circle bisects the circumference of the other circle, what do you mean? Tell me, what do you mean? Huh? When one circle bisects the circumference of the other circle, what do you mean? So both these situations are holding true. First situation is that circle is touching a line at origin, okay? And second situation is that the circle is bisecting the circumference of C1. Can you, both the scenarios, can you write it in mathematical language? Now I'll tell you a very big, I would say, mistake which students commit. A very big mistake which students commit is they try to, in order to compute the equation of circle C, they try to write the equation of circle C as x square plus y square plus 2gx plus 2fy plus c equal to 0 or plus lambda equal to 0, whatever. But when you do that, when you write the standard equation of circle C, it has GFs and lambda. GF and lambda, 3 unknowns. I have to do so much of hard work. I have to consume so much of my time, my head, my energy, my space to actually compute 3 unknowns, GF and lambda. Very lengthy process. Not wrong, but very lengthy process. And that is a big, big mistake which students commit whenever they're given a situation like this where a circle is touching a line at some point and the line's equation is given to you. You are in search of the circle's equation. Always in this situation, use the shortcut. Always in this situation, use the shortcut. What is the shortcut? The shortcut is family of circles. Yes, people, whenever, please remember this, whenever you have a fixed line L equal to 0 and there is a point known to you which is x1, y1, there can be infinitely many circles touching the line at this point. There can be infinitely many circles touching the line at this point. Any circle sitting in this infinite family of circles, how does it look like? It has a specific equation. It looks like x minus x1 whole square plus y minus y1 whole square plus lambda L equal to 0. Yes. For different values of lambda, you will keep on getting different equations of all these circles which are touching my line L at x1, y1. This is a concept you are not allowed to forget. This is not something which strikes immediately, but it should strike immediately, especially whenever you see a situation like this where a circle is touching a line at a point, line's equation is known to you, points coordinates are known to you. Please use the shortcut. Don't go by the approach of writing the standard equation of the circle. It has 2, 3 unknowns. Why do you want to put in that much time and hard work, right? When we have a shorter approach. This only has one unknown, which is lambda. Can you see this? This has only one unknown. Only one unknown. Yes or no? Correct? So how will my circle C's equation look like? X minus 0 whole square plus y minus 0 whole square plus lambda L. L is what? This is representing L. L equal to 0. So x minus y is 0. So you are getting what? X square plus y square plus lambda x minus lambda y is 0. This is my circle C's equation. Okay, let's come to another fact which is given to us about circle C. Right now, lambda is not known to me, but let me come to the next fact, which is circle C is bisecting the circumference of C1. Understand the language, try to interpret the meaning of it. Try to interpret the meaning of it. What do you think? C is bisecting the circumference of C1. What does that mean? What does that mean? Bisecting the circumference means dividing it into 2 equal halves. Dividing the circumference into 2 equal halves means each one of them is a semicircle. But it's the diameter actually which divides my circle into 2 equal halves, which means circle C bisecting the circumference of C1 implies that the points of intersection are actually the end points of the diameter. So when I say C bisects the circumference, C bisects the circumference of C1, this implies points of intersection are end points of the diameter of C1. The points of intersection at which my circle C is cutting C1, they are nothing but the diameter of C1, which implies AB is actually the diameter of C1. This means what? One more thing you can see very clearly out loud. AB is actually, bache, representing the common chord. No. AB actually is representing the common chord. It's representing the common chord of these two circles. So what can I say? Common chord. Common chord is actually the diameter of the smaller circle. Common chord is the diameter of the smaller circle, and it also means one more thing. Very important. Please listen to this analysis. If the common chord AB is the diameter of C1, the diameter always passes through the center. So somewhere here will lie the center of C1. So one more thing is guaranteed, that common chord in this situation passes through the center of C1. So many equivalent implications. Equivalent, all are equivalent. All are equivalent. C bisects the circumference of C1 means what? Points of intersection of C and C1 are nothing but endpoints of the diameter of the smaller circle. Right? But the diameter is actually the common chord. And common chord passes through the center. Or diameter passes through the center. So in this case, common chord passes through the center of the smaller circle. Is that making sense? Please tell me. Please tell me if there is any problem. Please tell me. Yes? Now the actual magic starts. Why and how? Because the equation of common chord is what? Tell me. S minus S dash equal to 0. In this case, it will be C minus C1 equal to 0 or C1 minus C equal to 0. Anyway, yes or no? This is the equation of common chord. This is the equation of common chord. So what is the equation of the first? C1 minus C equal to 0 if you say, then x square plus y square plus 2y minus 3. This is C1 and this is C. Yes or no? What was the equation of C? Remember, what was the equation of C? X square plus y square plus lambda x minus lambda y equal to 0. Yes? That's what I'm going to write. X square plus y square plus lambda x minus lambda y equal to 0. So, C1 minus C equal to 0. This is representing the equation of common chord, that is your AB. Correct? Now, simplify. Plus, plus, minus, minus. So, you have what? Minus lambda x plus lambda y plus 2y minus 3 is 0. So, minus lambda x plus y common lambda plus 2 equal to 3. This is the equation of my common chord. Okay. This is the equation of my common chord AB. Okay. 2y minus 3, then minus lambda x plus lambda y. Okay, fine. Okay, fine. Now, because the center of C1 lies on the common chord, because my common chord actually in this case is the diameter of C1. What is C1's equation? X square plus y square plus 2y minus 3. What will be the coordinates of its center, bachche? What will be the coordinates of its center? Minus g comma minus f. Minus g, there is no x or coefficient of x. There is no x term, so it will be 0. And minus 1. 0 comma minus 1 will be the center. Everybody quickly tell me. Minus g comma minus f, minus half of coefficient of x comma minus half of coefficient of y. Coefficient of y was 2, minus half of it will give you minus 1. So 0 comma minus 1 actually lies here. Plug in x as 0, plug in y as minus 1. So you get minus lambda minus 2 is equal to 3. So you are getting minus lambda is equal to 5 or lambda is minus 5. Are you getting lambda is minus 5? I have a smile on my face because I have figured out what lambda is. And my equation of the circle which I was searching was circle C. It was circle C. I want the equation of my circle C, no? And it is this. X square plus y square minus 5x plus 5y. X square plus y square minus 5x plus 5y equal to 0. Just plug in lambda is minus 5 and you've got your answer. Just plug in lambda as minus 5. So x square, this is 2x square, okay. X square plus y square minus 5x plus 5y. D is the right answer. X square plus y square minus 5x plus 5y is 0. D is the right answer. Is this question bang on clear, everybody? Please tell me. It's a very beautiful question based upon many concepts. Until and unless you don't draw the figure, a rough figure, either you draw it or you imagine it, visualize it in a very perfect sense. Until unless you do this, you will not be able to reach to the family of circle shortcut. You will not be able to understand this setup as well. So please draw it. Please draw the figures and accordingly see what are they implying. How to convert the English language or a geometrical figure into a mathematical language. Very important question, guys. Big takeaway from this question. I hope you understood it. I hope it's hashtag HDCC everyone. The concept was clear to you of circle touching a line at a point, and also the concept of one circle bisecting the circumference of the other circle. Both very famous concepts and very loved concepts by NTA. I hope questions still here are hashtag HDCC everyone. Let's go to the next one. Very important again, coming from the world of conic sections. A series of concentric ellipse. Okay. Alright, a series of concentric ellipse E1, E2, E3 up till En are drawn such that En touches En minus 1 at the extremities of the major axis of En minus 1. Foci of En coincides with the extremities of minor axis of En minus 1. If the eccentricity of the ellipses is independent of n, then the value of eccentricity is what? When it says eccentricity of the ellipses is independent of n, this means all ellipses, no matter it's E1 or E2 or E3 or E4 or E5 or E6 and so on or En, all ellipses have same eccentricity. That's a very important observation. All ellipses have same eccentricity no matter what is the number below, E1 or E2 or E3 or E4, 5, 6, 7 and so on. I don't care. Independent of n. Eccentricity is independent of n. So when I say eccentricity of E1, it is actually equal to eccentricity of E2 equal to eccentricity of E3 and so on equal to eccentricity of En. Now this question might look like a heavy question because the language seems a little heavy. What do you think? What do you think? How do you think you should crack this? Tell me. How do you think you should crack this? Please remember, when you have ellipses E1, understand the language E2, E3, E4 and so on, En minus 2, En minus 1, En. All these are ellipses. The question says En touches En minus 1 at the extremities of its major axis and the foci of En coincides with the extremities of minor axis of En minus 1. This is the relationship between En and En minus 1 and this is true for every n. That means the same is the relationship between En minus 2 and En minus 1. Same is the relationship between E3 and E4, E4 and E5, E2 and E3, E1 and E2. So when you write it like this, between any two consecutive pair of ellipses, there is the exact same relationship being followed. What is that relationship? That En touches En minus 1 at the extremities of the major axis of En minus 1 and the foci of En coincide with the extremities of the minor axis of En minus 1. This statement is written corresponding to En and En minus 1. You replace n with 2, n minus 1 with 1 and the same is going to follow for E1 and E2. You replace n with 3, you will get the same relationship being followed with E2 and E3. Yes or no? Yes or no? You replace n with 4, same relationship is being followed between E3 and E4 and so on. So if between any two consecutive pairs of ellipses, the same story is being practiced, why do you want to make life tough for you? Just pick up E1 and E2 and do the analysis. No. Whatever conclusion you will get corresponding to this pair, same will be the conclusion corresponding to every pair of consecutive ellipses. Same conclusion. Yes or no? It will be the same conclusion, no variation at all. On top of that, eccentricities are also same. So absolutely confirmed statement is this, that between E1 and E2, whatever is the conclusion you are getting, same is going to be between E2 and E3, E3 and E4 and so on, En minus 1 and En. So this is the trick of this question and you have to remember this. The trick is only work with E1 and E2. Is that making sense? Only work with E1 and E2. Only work with E1 and E2. Only work with E1 and E2. Now let's start. E2 touches E1 at the extremities of the major axis of E1. So somewhat like this, let's say is E1. Somewhat like this, let's say is E1. Okay, I'm going to draw it again. somewhat like this is, let's say, E1. Okay, fine. E2 touches E1 at the extremities of its major axis. Major axes are ending here and here. This is my E1 ellipse. My E1 ellipse is actually, I've drawn it to be a horizontal ellipse. I've drawn it to be a horizontal ellipse. It looks like what? What is its equation? X square by A square plus Y square by B square equal to 1, where A is greater than B. So this point looks like A comma 0. This is minus A comma 0. This point is 0 comma B, and this is 0 comma minus B. This is origin, standard ellipse. Now draw E2. When you draw E2, you will draw it to be something like this. Yes, not very neat figure, but I hope you understood. This white is E2. What is it satisfying? It is passing through the extremities of the major axis of the horizontal ellipse, and its foci are the extremities of the minor axis of the horizontal ellipse. That means this is and this is the foci of E2. Foci of E2 will look like what? See, E2 is my vertical ellipse, as you can see from the diagram. Its equation will be x square by A square, capital A square, plus Y square by B square is equal to 1, where B is greater than A. So accordingly, its foci are going to have coordinates 0 comma BE, and this will be 0 comma BE. Now I will deliberately not write E as eccentricity of E2 or eccentricity of E1. I should technically, but I will not be writing the lower indices of E1 and E2 because all the eccentricities are the same. No matter what the ellipse, eccentricity is the same. That's why I'm just writing BE. I'm writing just E, not E of E1 or E of E2. Is this making sense? Everybody please tell me. Yes? Now listen to me carefully. Once you've drawn the figure, you have three equations with you. How you have three equations? For horizontal ellipse, let me write it for E1. For horizontal ellipse, what is the eccentricities equation? 1 minus B square by A square. Please tell me if this is clear. Yes? For E2, what is the eccentricities equation? 1 minus A square by B square. It's square of the smaller upon square of the bigger. So in E1, B is smaller than A, so B square by A square. In E2, A is smaller than B, so A square by B square. But it's always square of the smaller upon square of the bigger. Another thing which you can very easily see from here is, bache, foci is done. What is this and what is this for vertical ellipse? This is actually A comma 0 and this is minus A comma 0. Yes or no? Yes or no? So from here again, two things are being highlighted, that small a is equal to capital A and small b is actually equal to capital B. Small a is equal to capital A and small b is equal to capital B. Tell me. Tell me if this is understood. Come on, you can tell me in the chat. Tell me if this is understood. Yes, small a is same as capital A, small b is equal to BE. Now, I have this and this and this. All of them are holding true. If I catch hold of this equation, I have B is equal to BE, square both sides. This is what you get. This is E square. E square. Yeah, E square. You get this? What is small b square? Can you tell me? And what is capital B square? Can you tell me? What is small b square? From here, you will get A square E square is equals to A square minus B square. So B square is A square common 1 minus E square. So B square is A square common 1 minus E square. Similarly, what is capital B square from here? Tell me. B square E square is equals to B square minus A square. So you are getting A square is equals to B square common 1 minus E square. So what is B square? A square upon 1 minus E square. Is this the case? Come on, come on, come on. Tell me in the chat. Tell me in the chat. Capital B square is actually A square upon 1 minus E square. But capital A square is same as small a square, na? Okay, fine. Into E square. A square cancels out. What are you left with? 1 minus E square whole square is equal to E square. So 1 plus e to the power 4 minus 2 E square minus E square is 0. That means you are getting e to the power 4 minus 3e square plus 1 is 0. What is this? What is this? I have to simplify this and get the eccentricity. No, e to the power 4. E to the power 4 minus 3e square plus 1 is 0. You can write this as what? T is obviously positive. You will get t square minus 3t plus 1. Solve this. Minus b plus minus root over b square minus 4ac upon 2a. So you are getting 3 plus minus root 5 upon 2, which gives you two values. 3 plus root 5 upon 2, 3 minus root 5 upon 2. Now root 5 is 2 point something. Obviously both are positive, but root 5 is 2 point something. So 3 plus 2 point something is 5 point something upon 2 is greater than 2. This is greater than 2. Isn't that a problem? Isn't that a problem? If t is greater than 2, t is nothing but e square. If e square is greater than 2, that means e is greater than root 2. If e square is greater than 2 and e is a positive quantity because it's an eccentricity, e is greater than root 2. That means greater than 1.414. But that's not allowed in an ellipse, no. In an ellipse, my eccentricity has to be fractional. It has to be sandwiched between 0 and 1. So I am not allowed to take this value of e square because it will mean eccentricity is greater than root 2 or eccentricity is greater than 1. Not allowed. This is something which I will accept. Is this cool? So you are getting e square is equals to 3 minus root 5 upon 2. Can you tell me what is this square of? Can you tell me what is this square of? This is root 5 minus 1 by 2 whole square. So your eccentricity, which is a positive number, comes out to be root 5 minus 1 by 2, sitting in option B. Please check, root 5 minus 1 by 2 whole square is nothing but 3 minus root 5 by 2. This is a very subtle but a very, very important calculation hack. When students script that, ma'am, math is so lengthy. Oh my God, ma'am, math is so lengthy. It is so time consuming. The calculations are so irritating. It takes so much of time. The arithmetic calculations are so heavy. I am like, please start remembering some of the values, no? Save time. Play smart. Like trigonometric values of special angles, please remember them by heart. Formulas, please remember them by heart. Some of the square roots and logarithmic values, please remember them by heart. Squares like these, that 3 minus root 5 by 2 is root 5 minus 1 by 2 whole square, please remember them by heart. When you remember these things very well, like at the back of your hand, if you remember them, at the drop of a hat, you can tell me, what is this, what is this, what is this? It really, really accelerates your speed in the paper. Because you are not sitting there and using a hit and trial approach. You are not sitting there and struggling as to what will be this value. Will it be positive or negative? What is the answer of this quantity? Many, many things you will be able to write in a smooth fashion because you remember them. So please use the fact that you have a memory, okay? And please keep polishing it. Start feeding it as much as you can. The more you feed, the more it will expand. The more you feed, the more it will expand. So few things like this. Square of this, log values, square root values, trigonometric values of certain angles, special angles, 15 degree, 75 degree, whatever. Try to remember them. It will really help you amplify your speed. Now, before I move on to the next question, is this question absolutely clear? Guys, even if the question had a massive language, it was like a paragraph, I am not denying. But even then, I would like to say that the question was not based upon any nuclear bomb concept as such. The question was completely based upon the concept of eccentricity, the concept of foci, the concept of vertices, co-vertices, the concept of relationship between A, B and E. These are all very basic facts about an ellipse which are tested in every exam. In whichever exam you get conic sections, these fundamentals about any conic section, be it ellipse or hyperbola or parabola, anything, they are tested, and that is what this question also tested, but in a very fancy manner. So don't judge a book by its cover. Don't look at a question and be like, oh my God, n ellipses. I actually did not work out with n ellipses. I actually worked out with just 2. And that solved my purpose. Yup, I hope this question is absolutely clear. Let's go to the next one. Ready? Is this question hashtag HDCC? Hashtag HDCC, everybody. Let's go. Let's go. The equation of a curve passing through 1, 0 for which the product, oh my god, this is a fantastic question. Okay, let's read the statement. It's a fantastic question. Equation of a curve, I don't know what the curve is, passing through 1, 0 for which the product of the abscissa of point P and the intercept made by a normal at P on the x-axis is equal to twice the square of the distance of the point P from the origin O is what? Tell me. Tell me. Equation of a curve passing through 1, 0 for which the product of the abscissa of a point P and the intercept made by a normal at P on the x-axis is equal to twice the square of the distance of the point P from the origin. Confusing. Confused, right? Let's break it. Whenever a statement overwhelms you because it has too many words, very dense language, too much interconnection of words, I want you to break it down. Break it down into smaller pieces, smaller parts, and take a look at every part. Equation of a curve. I have a curve. Okay, I have a curve passing through 1, 0, passing through 1, 0, for which the product of the abscissa of a point P. So there is some point P. There is some point P, okay, for which the product of the abscissa of a point P and the intercept made by normal at P. So this is your tangent at P. This is your point P, right? And this is your, let's say, normal at P. This is your tangent at P and this is your normal at P. And P, let's say, looks like x1, y1. Okay, this is my curve. I hope now things are a little clear. There is a curve passing through 1, 0, okay. But there is another point P whose abscissa I am interested in. Abscissa is the x-coordinate. And the intercept made by the normal on the x-axis. Intercept made by the normal on the x-axis. So I want the normal's equation. Until and unless I have the normal's equation, I can't intersect it with the x-axis to find the x-intercept. Got my point? So what will be my normal's equation? If I talk about normal at P, what will it look like? I want a point, I want the slope. So point slope form will help me write the equation of normal. So y minus y1 is equals to slope of normal into x minus x1. Now I know as a matter of fact, my curve is nothing but y equal to f of x. If my curve is this, I know dy by dx at point P represents slope of tangent. And slope of normal is negative reciprocal of slope of tangent. So minus dx by dy at point P will give me slope of normal. How many of y'all have understood this? Yes? Yes, slope of tangent is derivative of the function at point P. Its negative reciprocal will give me slope of normal. So I will have y minus y1 is minus dx by dy at point P into x minus x1. Now keep looking. If I intersect this with x-axis, I will get the value of x which will give me the x-intercept. So intersecting it with x-axis means y equal to 0. Plug in y as 0, you will get minus y1 is equals to minus dx by dy at point P into x minus x1. I want x. So this minus cancels out. You are left with y1 into dy by dx. Things got reciprocated, guys. Is equal to x minus x1, or you add x1 here and this is your x. This is your x. That means this actually is playing the role of your what? Guys, x-intercept. This is your x-intercept. X-intercept which is created by the normal with the x-axis. Is this making sense? Everybody please tell me. Making sense? Now what? I want the product of the abscissa of point P and the intercept made by the normal on the x-axis. Product of abscissa of point P. So P is what? x1, y1. Product of its abscissa with the intercept. Intercept is what? x1 plus x1 plus y1 times dy by dx at point P is equal to, yeah, this is the x-intercept. So product of abscissa with the x-intercept, this is equal to twice the square of the distance of the point P from origin. Point P is x1, y1. Its distance from origin, which is 0, 0. What is it? Under root x1 square plus y1 square, that's the distance. I want its square. So under root x1 square plus y1 square, I want its square. This is bingo, the very step you had to reach. This is the very step you had to reach, because this is nothing but a differential equation when you simplify it. The question is of differential equations. Right in the beginning, it did not seem like it, but this entire story you had to decode. Geometrically also, mathematically also, you had to decode whatever was written in English. You had to convert it into the language of math. And then it actually gave you a differential equation. Still, it has not given you, because I want you to first of all replace x1, y1 with x comma y. Because I want to talk about any x and y, right? Just to give it a specific identity, I wrote it as x1, y1, but actually it's representing x comma y. So it is x into x plus y dy by dx at point P. P is x comma y only, so this is done, equal to x square plus y square. So here also you have x square plus xy, this. So x square cancels out. Does it? Quick, think. Think, no? Oh, twice the square. So 2x square plus 2y square. Okay, so you are getting xy y dash is equal to x square plus 2y square. Who will tell me what is this type? Huh? What is this type? Tell me. Xy dy by dx is equal to x square plus 2y square. This is a differential equation, bache. This is a differential equation, but what type of a differential equation? Can you tell me? Anybody? Waiting for your response. Who will tell me? Huh? X square plus 2y square. And on the left hand side, it's xy. Can you see? The degree on the left, the degree on the right. Same. It's a homogeneous differential equation. It's a homogeneous differential equation. This is homogeneous differential equation. Yes? Is that clear? Is that clear? If there's any confusion, please tell me. If there is any confusion, please tell me. Because you know what to do. You plug in y as vx, dy by dx is equals to v plus x into dv by dx. So you get what? V plus x into dv by dx. X into y. Y is vx. So vx square on the left. And on the right, this is x square plus 2 times v square x square. So v square, this is v square, no? Y, x square. So x square gets cancelled out. You are left with what? V square, or rather, v plus x into dv by dx is equals to 1 upon v plus 2v. Please tell me if this is clear. And 2v minus v will give you just v. So 1 plus v square upon v. Yes or no? And this is 2v square, no? 1 plus v square upon v. Please tell me. Please tell me if this is clear. Tell me. X into vx, so you get vx square, and dy by dx is v plus x into dv by dx. That is cool. X square plus 2 times v square x square. Is this cool? Okay. 1 upon v and 2v. Please tell me if this is clear. Tell me if this is clear. if you do not want to use the conventional setup of plugging in y as vx, you can do one more thing. Alternatively, I'm saying, you can do one more thing if you don't want to plug in y as vx, which is something we used to do in schools in 12th from our NCERT or school exam perspective. You can directly write dy by dx is equals to x square upon xy will give you x upon y, plus 2 y square upon xy will give you y upon x. Now plug in y by x as v. It's the same. It's the same, only y equal to vx. So dy by dx is equal to v plus x into dv by dx. That is the same, but this will be v plus x into dv by dx. X by y. What is x by y? It is 1 upon v, and this is 2v. Yes, ma'am, no, ma'am. Same equation you've got, no? So x dv by dx is equals to 1 by v plus v. So 1 plus v square upon v. Exact same thing like you were getting before, just a little faster. So v upon 1 plus v square, no space, no space. I'll write it here. See, v upon 1 plus v square dv is equal to dx upon x. Now what you do is, you know what to do. Variable separable, see, I converted into variable separable, and that's why I'm integrating both sides. Multiply this by 2, multiply this also by 2. Now you know when you take 1 plus v square as t, you get 2v dv is equal to dt. 2v dv is dt, so you get integration dt upon t. Integration dt upon t, this is 2 times integration dx upon x. So you get log t, t is 1 plus v square is y square by x square is equals to 2 log x plus log c. 2 log x means log x square. So you are getting 1 plus y square by x square, which means what? X square plus y square by x square is equal to what? Cx square. Or x square plus y square equal to cx to the power 4. Now the question says curve passes through 1, 0. If the curve passes through 1, 0, bache, plug in x as 1, y as 0, you get c equal to 1. So your answer is x square plus y square equal to x to the power 4. X square plus y square equal to x to the power 4. Please check if there is any confusion in the entire flow. Yes, a lengthy question. Yes, a question which I would strongly recommend you to not at all attempt in the first round. Please don't attempt in the first round. But it's a very doable question because the only trap they are trying to lay for you is the language of the question. If you somehow gather that strength, that courage, that character, and that peace of mind, that calmness, that, control over your nerves to read the statement, make sense of it in that pressure situation, convert it into mathematical language. After that, it is a cakewalk. It's literally very simple because the moment it's homogeneous, then you know what to do. All this is very simple. It's a very simple homogeneous equation. I hope this question is also hashtag HDCC, everyone. Yes, ma'am. No, ma'am. Yes. Is this completely understood? Let me know in the chat. Is this completely understood? Yes. I'm going to move ahead now. Look at this equation. This is fantastic, fantastic, fantastic. All questions that I have today, I love every question that I have brought for you today, and I am thoroughly enjoying discussing them with you. Thoroughly enjoying. Tell me, this is also fantabulous and very famous category, guys. Very, very famous category of questions. Please make sure that you are able to understand the soul of it. I am not saying this same question will get repeated in the paper, but what I'm trying to say is the questions are representing a variety in themselves. They are representing a certain variety. Every question is being driven by a concept, by an idea, by an approach, which is the major takeaway for you. That I want you to take away. Any question which comes from the same concept, of the same idea, of the same approach, you should be able to crack it. All right, that's the idea. Question says number of values of x satisfying this equation for mod x lying between 0 and 2 strictly. Please make sure you understand the question. It's not tan and cot, it's tan inverse and cot inverse. Now, two things are striking the moment look at this equation. Two things automatically are striking. One thing is You have tan inverse of something plus cot inverse of something equal to pi by 2, right? Okay, you know as a matter of fact, tan inverse of something plus cot inverse of something is equal to pi by 2. When is this valid? This is a very famous result, a very famous formula. When is this valid? You have the same type of a formula for sine inverse and cos inverse and secant cosec. But when is this valid? Tan inverse something plus cot inverse something. This is valid, that this is equal to pi by 2 if and only if both these arguments are same. Same and coming from the domain of tan inverse and cot inverse, which is set of all reals. So this is a very subtle, very small thing, but a very important thing. Very important, that tan inverse of something plus cot inverse of something is pi by 2 if and only if both these brackets are actually alike. They have the exact same photocopy quantity sitting inside them and it is a real quantity. Then it is equal to pi by 2. And another thing which I am able to decode from here is that when you say mod x is sandwiched between 0 and 2, what do you mean? This means x lies between minus 2 and 2 except 0. Mod x is 0 only when x is 0. But when you say mod x is positive, means x equal to 0 is not allowed. So mod x sandwiched between 0 and 2 strictly means x is sandwiched between minus 2 and 2, open interval, minus singleton 0. Both these things, are they clear to you? And they should strike you the moment you see a question like this. Immediately the result to pop up in your head should be tan inverse of something plus cot inverse of something is pi by 2 if and only if that something is actually the same real quantity. Okay, has to be photocopy. In no other scenario can this actually hold true. And the second thing which should pop up in your head is that mod x lying between 0 and 2 means x is sandwiched between minus 2 and 2 strictly except 0, puncture 0. Okay, so I have got the hint to solve the question. Tan inverse of something plus cot inverse of something pi by 2. If this is pi by 2, this clearly implies that both these quantities a and b are actually real and equal. So a is equal to b. There is no other case. In no other situation can this hold true. So this implies x minus x cube by 4 plus x to the power 5 by 16 minus and so on is equals to x plus x square by 2 plus x cube by 4 plus and so on. They both are equal. This is the magic you have to reach to. Because the moment you reach here, what you must realize is ki bachche, this is a geometric progression. What is the first term? First term is x, and what is the common ratio? Minus x cube by 4x. X cancels out, you get minus x square by 4. X is positive, no? Remember? Not x is positive, mod x is positive. X is lying between minus 2 and 2 and it's not equal to 0. That's why I'm able to cancel the x up and down. Because x is non-zero, I am allowed to cancel. So this is a GP, infinite GP with first term x and common ratio minus x square by 4. Even this is a GP, you guessed it right. Even this is a GP with first term x and common ratio is x square by 2x. Again, this gives you x by 2. Now, problem is, till here though it's fine. Problem is, if I want to compute the sum of this infinite GP, I know as a matter of fact, sum of an infinite GP is given by a upon 1 minus r if and only if mod r is less than 1. How many of you all remember this? If and only if mod r is less than 1, then only your infinite sum of GP converges to a minus r. Then only it has a finite sum which is given by first term upon 1 minus the common ratio. But can it happen in this situation? Yes, it can happen. Why? Because common ratio mod r1, you see it is mod of x square by 4. You know mod x is less than 2. So means what? This is less than 1. Are Baba, if mod x is less than 2, it's given to you. That means square is less than 4. So mod x whole square upon 4 is less than 1. But mod x whole square or mod of x square is the same. So this implies what? Mod of x square upon 4 is less than 1. It's the same, na? Mod x whole square upon 4 is less than 1. That means mod R1 is less than 1 and hence I can apply my sum of infinite GP formula for the left hand side GP series. For the right hand side, let's check. Mod of x by 2. This is definitely less than 1. If mod x is less than 2, mod x by 2 is less than 1. Na? This implies R2. Mod R2 is also less than 1. So again, even I can apply my sum of infinite GP for the second GP series. So very, very tiny justification. Many students don't even do this. They blindly go and apply the a upon 1 minus r rule. In this case, yes, both mod R1 and mod R2 are coming out to be less than 1. But generally, it might happen that some side it's valid, some side it's not valid. So you have to make sure you always check, always check the conditions which are required for a result to stand true. Got it? So what was my left hand side? A upon 1 minus r, x upon 1 plus x square by 4. Right? X upon 1 plus x square by 4 is equal to, what is my right hand side? A upon 1 minus r, x upon 1 minus x by 2. Very good. Now x I know is between minus 2 and 2, but it's not equal to 0. So I can comfortably cancel this out. 1 minus x by 2 is equals to 1 plus x square by 4. So you are getting 2 minus x is equal to 4 plus x square, and this is upon 2. So this gives you 4 and this gives you 2x. Okay, alrighty. So x square plus 2x is 0. This gets cancelled out. So you are getting x into x plus 2 is 0. So x is coming out to be 0 and minus 2. Two values I am getting, 0 and minus 2. Two values means two answers. C is correct. Yes or no? Can I say my option C is correct? Everybody please tell me right now. Because I wanted all the values of x for which this is holding true, and it is holding true. No, this is holding true for x equal to 0 and minus 2. So there are two possible answers. I can mark C as the right option, right? What? Can I not? Can I mark C as the right option or not? Can I mark C as the right option? Yes or no? Tell me. No, I can't, because I have to remember the restriction on x. X lied in the interval open minus 2 comma 2 except 0. Except 0. Minus 2 not allowed, 2 not allowed, 0 not allowed. Everything lying strictly between minus 2 and 2 except 0, that is allowed. It can't be 0, it can't be minus 2. There are 0 solutions, bache. It's not 2, it's 0. A is the right answer. Such a fantastic question. This had a good slippery area. This had definitely a concept which not many students would be comfortable with. This had a tricky sense involved. Yes or no? And that is why it's a must do. This question is a must do. Is this hashtag HDCC? I want you to tell me in the chat right now. Is this absolutely clear? Is this absolutely clear? Yes or no? Yes or no? Tell me, reading the chat. Quickly tell me. Quickly tell me. Absolutely clear? Hashtag HDCC? Awesome job done then. Let's move forward. Let's go ahead to the next question. This is a very famous, very famous and highly repeated category. Highly. Very famous and highly repeated category, something which you must know how to crack. Like this is a type of question which you have to remember how to crack. It's so important. It's so important and its approach is so obvious and so standard. There is a fixed approach to solve this. You should know the approach and the question is done. It's done and dusted. Literally, it's done and dusted. What do you think? Come on, write it down properly. X to the power 1005 plus root over x to the power 2010 plus 1. All of this whole square upon x to the power 4021 dx. Let me just concentrate on the integrand and I'm obviously going to integrate it in the end. Whenever you have such an integrand, what do you do? Tell me. Tell me. When you have such an integrand, what do you do? Think hard. I'm sure you will be able to tell me. What is it? What do you do? When you have such an integrand, what do you do? When you have such an integral, what do you do? To simplify it, to solve it. The trick is, or the approach is, the idea is, the standard fixed method is, take the highest power common. Now the highest power common from the numerator is x to the power 1005. X to the power 1005. So what am I going to do? X to the power 1005 as it is. I will take out x to the power 2010 common from here. And you'll be left with 1 plus 1 upon x to the power 2010. All of this whole square upon x to the power 4021 dx. Correct? Now, when x to the power 2010 comes out of the square root, what do you get? X to the power 1005. Same thing that I wanted. So, x to the power 1005 plus x to the power 1005. Inside you have 1 plus 1 upon x to the power 2010. And all of this whole square upon x to the power 4021. Tell me if there is any confusion. Please tell me if there is any confusion. So x to the power 1005 has come out common. 1 plus root over 1 plus 1 upon x to the power 2010. This whole square and this whole square. Whole upon x to the power 4021, and this is dx. Tell me, this final power becomes what? 2010. Right? Cancel this. What are you left with? 4021 minus 2010. So 1 here, 0 here, 2 here. 2011 is what you're left with. 2011. This is what you are left with. No. So in the next page, you write it down. Now you have a final integral with you. This is root over 1 plus 1 upon x to the power 2010 whole square. Yes or no? 1 plus. Okay, 1 plus this whole square upon x to the power 2011. Can you tell me now what will you do? Now it's very obvious. Actually, it's very obvious. Tell me. It's very obvious. Now the question has been simplified completely. Now what you do is get rid of the square root, no? Get rid of the square root, no? What will you do? How will you get rid of the square root? Whatever is written inside the square root, 1 plus 1 upon x to the power 2010, take it as t or t square. If you take it as t square, things will be simpler for you because under root t square will give you just t. So take it as t square. T also will work. Take it as t square. So you get x to the power minus 2010. So differentiate minus 2010 x to the power minus 2011. That means 1 upon x to the power 2011 dx is equal to 2t dt. This is 1005. So dx upon x to the power 2011 is equals to minus t upon 1005 dt. Perfecto! Perfecto! In the next step, what do you get? Okay, I'll write here. 1 plus under root t square is t and all of this whole square upon x to the power 2011. This is dx. So dx upon 2011 has come out to be minus 1 upon 1005 t dt. Wow! This is a very simple integral. Can you crack this now? Can you crack this? Minus 1 upon 1005 is chalo fine. This will give you this plus this plus this. And then you know what to do. This is t square by 2 plus t to the power 4 by 4 plus 2t cube by 3. All of this plus c, and outside you have minus 1 upon 1005. just plug in t or t square as this quantity. And t will be under root of this quantity. And eventually you will get option D as the right answer. So in the end, it's only substitution game and further simplifying it by 1 or 2 steps. But when you see the pattern matching with any one of the 4 options, it will be D. Even if halfway the pattern matches, mark D. The main idea, the main takeaway rather from this question is, this is a very standard variety, very common variety, and I want you to please understand the method to crack it. It's very repeated, and I don't know why this was very old, in very old times this was asked in advanced exams, and now this has been started coming in the mains exams. The idea is always take out the highest power common, take out the highest power common, take out the highest power common, and accordingly manipulate the expression sitting inside here so that you have the highest power out common. Okay, is that cool? After that, you know how to substitute t or t square, and then so it is a very standard game. You know how to play that game. Alrighty, coming to the next question. I hope the previous one was hashtag HDCC. Everybody in the comments right now. I want you to load the comments with hashtag HDCC. Is that making sense to all of you? Yes or no? Cool? Come here. The number of points lying inside the circle or on the circle and satisfying this equation is how many? The number of points lying inside the circle or on the circle and satisfying the equation is how many? How many? Tell me. Very important. Supremely important. It's a mix of geometry and trigonometry. Can you see that? It's a mix of the concept of circles and concept of your tan, cot, sine function. Beautiful mix of trigonometry and geometry. Very beautiful. Favorite of JEE Main. Favorite. Can you tell me? If you look at the circle x square plus y square equal to 9. So it's like a, what? It's a circle centered at origin. Radius 3 units. Radius 3 units. This is 3, 0. This is minus 3, 0. This is 0, 3. And this is 0, minus 3. So one thing is sure, if x, y is lying inside the circle or on the circumference of the circle, that means x is ranging from minus 3 to 3 and y is also ranging from minus 3 to 3. Yes. Or I can say that x, y belongs to minus pi, pi. 3 is very close to 3.14. So if I want to kind of bring the geometry aspect in picture, because I have to connect trigonometry with geometry. So geometrical thing, I understood that points lying on the circle and inside the circle. Fine, cool, okay. But if I want to bring the trigo part here, instead of saying x, y are lying between minus 3 and 3, it's better and more refined for me to say that x, y are sandwiched between minus pi and pi roughly. 3 and 3.14 not very different. I can say x and y are sandwiched between minus pi and pi. This is going to transform me or transfer me, teleport me to trigonometry. Yes or no? Yes? Now let's go to trigonometry. It's given tan to the power 4x plus cot to the power 4x plus 2 is equal to 4 sine square y. Here I want to share with you a very big hint. And this hint is something which you have to universally remember for any question like this. Universally, you have to forever remember this. Whenever you have an equation with two unknowns like x and y, over here you can see, with two unknowns, use the concept of range. Please remember this. You have x on the left hand side, y on the right hand side, and both sides are, question says they are equal. Tan to the power 4 plus cot to the power 4 plus 2 is equal to 4 sine square y. So they both are equal. Left hand side is dominated by variable x, right hand side is dominated by variable y. Always in such a situation, use the concept, the idea of range. Compute the range of the left hand side, compute the range of the right hand side. Is that cool? Let's start with the left hand side. Let's start with the left hand side. So left hand side is tan to the power 4 plus cot to the power 4 plus 2. Now tell me, please understand, tan to the power 4 and cot to the power 4 both are non-negative quantities, yeah? Even power of tan and cot always non-negative. So one thing which straight away should strike my head is, if I have two non-negative quantities, I can obviously use my what? Tell me. I can use my AMGM inequality. Yes, ma'am or no, ma'am? I can very well use my AMGM inequality, no? So let's start. They both are non-negative. Plus upon 2 is greater than equal to root over tan to the power 4 into cot to the power 4, which is 1. So you get tan to the power 4 plus cot to the power 4 is greater than equal to 2, or tan to the power 4 plus cot to the power 4 plus 2 is greater than equal to 4. So my left hand side I have got to know is at least 4. My left hand side I have got to know is at least 4. What about the right hand side? My right hand side is 4 times sine square y. Arey Baba, I know as a matter of fact that sine square y is always sandwiched between 0 and 1. Yes or no? Sine square y is greater than equal to 0, less than equal to 1. That means 4 sine square y is less than equal to 4. Or I can say my RHS is less than equal to 4. This is where you have to open your eyes wide and tell me what is the interpretation. If left hand side is at least 4 and right hand side is at least 3. Left hand side is at least 4, right hand side is at most 4. What did I say? Left hand side is at least 4, right hand side is at most 4, and they both are equal. Tell me, yes, you are correct. This can only happen when left hand side and right hand side are both equal to 4. Baba, my left hand side has range what? It is 4 or greater than 4. My right hand side says what? It is 4 or less than 4. So if they both have to be equal, they can only equal corresponding to both of them being equal to 4. Yes or no? So left hand side equal to right hand side if and only if they are equal to 4. Okay, that means left hand side is 4 and right hand side is 4. Yes or no? Left hand side 4 means what? Tan to the power 4 plus cot to the power 4 plus 2 is 4. That means tan to the power 4 plus cot to the power 4 is 2. How do you plan to solve this? Do you wish to write cot to the power 4 as 1 upon tan to the power 4? So tan to the power 8 plus 1. So tan to the power 8 is 2 minus 1, 1. So tan is plus minus 1. That is an approach which can also work. It can work. Write cot as 1 upon tan and then you will get tan as plus minus 1. This can work. But there is alternate approach. Even smarter. Even smarter. What is that? See, you know as a matter of fact that tan to the power 4 plus cot to the power 4 upon 2 is greater than equal to 1. This is AM greater than equal to GM. Yes. When I write this greater than equal to 2, it means the same thing. That your AM is greater than equal to GM. But when I say this is equal to 2, this means AM is equal to GM. Because it's almost like saying this upon 2 is equal to 1. Then only you will get tan to the power 4 plus cot to the power 4 upon 2 equal to 1. No. So this is like AM is equal to GM, which can only happen if the terms are equal. So tan to the power 4 equal to cot to the power 4. So you are getting tan to the power 4 plus cot to the power 4 upon 2 equal to 1. This means AM equal to GM, no baba, which can only happen if the terms are equal, which implies tan to the power 8 is 1 or tan is plus minus 1. This is one equation corresponding to x that I am getting, from where I'll get solutions for x. From where I'll get solutions for x. Okay, if I talk about the right hand side, it was 4 sine square y equal to 4. Right hand side equal to 4. That means sine square y equal to 1 or sine y equal to plus minus 1. Now the question says solve this to get y and solve this to get x, but keeping in mind that my x comma y are only sandwiched between minus pi and pi. Minus pi and pi. One revolution. So tell me, Tan is equal to 1. Where? Where all is tan 1? Tan is positive in first and third quadrant, A, S, T, C. In the first quadrant, we have pi by 4. In the third quadrant, we have what? Either pi plus pi by 4, which is 5 pi by 4, or minus pi plus pi by 4, which is minus 3 pi by 4. It's the same thing, and you want it from minus pi to pi, so you can't take it beyond pi. Pi plus pi by 4 will take it beyond pi. So instead, you can write it as minus pi plus pi by 4, which is minus 3 pi by 4. So x is coming out to be pi by 4 and minus 3 pi by 4 for tan x equal to 1. And tan x equal to minus 1 will give you what? Tan x equal to minus 1 in the second and fourth quadrant, tan is negative. So pi minus pi by 4 is 3 pi by 4 and minus pi by 4 is in the fourth quadrant. So minus pi by 4 and 3 pi by 4. These are the 4 angles corresponding to which tan is plus or minus 1 within minus pi and pi. Similarly, sin y is plus minus 1 inside minus pi and pi, inside minus pi and pi. Inside minus pi and pi will give you just one cycle, one complete cycle in which minus 1 will be attained at minus pi by 2 and 1 will be attained at pi by 2. So you get plus minus pi by 2. So x has 4 values, y has 2 values. So x comma y, how many ordered pairs? First coordinate x, which is abscissa, can be filled in 4 ways. Y, ordinate, second coordinate, can be filled in 2 ways. So both x and y can be filled in 4 into 2, 8 ways. 8 is the right answer. So if 8 ordered pairs x comma y, if x can be filled in 4 ways, y can be filled in 2 ways. So x comma y can be filled in 8 ways. Basic permutation combination, guys. Is this question clear? It's a beautiful question. I wanted to discuss this with you because this is a wonderful blend of geometry and trigonometry. Not many times you have access to such questions. But if you are getting access to these questions in this PYQ marathon, you must always remember not to leave the session without hitting the like button. And also, I'm warning you guys, please stay subscribed. All right, then let's go to the next question, which is this one. Fantastic, beautiful. Of course, I know when you read the statement of the question, the approach automatically pops up, isn't it? It says set of values of p for which this equation possess 3 distinct roots. This is one of the most famous and dreaded at the same time, that variety of a question. One of the most famous, most promisingly asked questions in the paper, but at the same time, students are very scared of this variety. I'll explain you very nicely. You know my style of teaching. We do a post-mortem of the question in every depth possible, right? We unlayer it, and then reach the answer. So how much ever knowledge, concept we can extract from a question, we do that. And that is what I do, so that in an exam-oriented manner, your preparation literally goes up. It gets refined, it gets better, it approaches perfection. Okay, let's go. Set of values of p for which this equation possesses 3 distinct roots. Well, what is the equation? Mod of ln x minus px equal to 0. If I send the px to the other side, what do you think is the scene? Can I do that? And if I do that, how will it be profitable to me? How will it be profitable? The only approach which should strike you in this situation, people, is the graphical approach. I want you to treat this as the left-hand side function, say f of x. This is your, let's say, g of x. If I draw the graph of both the functions in the same Cartesian plane, then analyze the situation, that is going to make me reach my answer faster. So it says set of values of p for which this equation possesses 3 distinct roots. Now understand my left-hand side function is what? My left-hand side function is what? Mod ln x. Let's go. Let's plot this. When I say ln x, this is my ln x. Yes or no? Quickly tell me, people. Very familiar function, very standard. This is my ln x. This is the value 1. When I say mod ln x, what does it mean? Mod ln x means, and you should know how to transform your function from f of x to mod of f of x. This means ln x when x is, tell me, non-negative, and minus ln x when x is negative. Yes? No? No. Mod ln x opens up how? Ln x when log x is non-negative, and it is minus ln x When log x is negative. So log x is non-negative means x is greater than or equal to 1, and log x negative means x is less than 1 greater than 0. Okay. So what happens whenever you have to transform your f to mod f? What happens? How do you transform your f to mod f? How do you transform your f to mod f? How do you transform your f to mod f? Tell me. Whatever portion of the graph is on and above the x-axis, it is kept intact, undisturbed as it is. And the portion which is below the x-axis, you flip it above the x-axis and bring it up. Okay, so what will happen? This portion which is below the x-axis, I will be removing it, and its mirror image above the x-axis will come above. So this is your mod ln x graph, wherein this branch which is after 1 is your ln x, and the branch between 0 and 1 is your minus ln x. So if I draw it properly, the graph for you of what? This is your mod ln x. Am I making sense, everyone? This is your value 1. Now, my left-hand side function is drawn. My right-hand side function g of x was nothing but p of x. Now, please understand, what does this represent? It's a linear polynomial. What does this represent? This is a line of slope p, yes, of course, passing through origin. 100%. Y equal to mx, you know, right? Y equal to mx means line passing through origin of slope m. So, y equal to px means line passing through origin of slope p. Now, when you say this, there are two ways to understand. One is this. If this line is y equal to px, obviously the angle it makes with the positive x-axis is theta, which is obtuse. So in this case, my p is negative because my angle of inclination is obtuse. So tan theta is negative. That means p is negative. But this situation doesn't work for me. It doesn't work in my favor. Why? Why it doesn't work in my favor? Because this line is not intersecting my log graph anywhere. It is not intersecting. No, so I'm not interested in p negative. I am not interested in p negative. If my p was 0, I would have got y equal to 0, which means x-axis. X-axis intersects my graph at only 1 point, not 3 points. So p can't be 0 also. P can't be 0, p can't be negative. That means p has no choice but to be positive. Did you understand? So here you have to understand why I am attaching the restriction of p being positive. I have to find out the value of p, a positive p for which this equation possesses 3 distinct roots, which means f of x equal to g of x has 3 distinct roots, which means both the graphs intersect each other at 3 distinct real points. Now please understand, when you say you have y equal to p of x where slope is positive, when your slope is positive, how does this look like? Your line will look like either this is your line, y equal to p of x with positive slope, but in this case there is only 1 point of intersection. If I draw it like this, yes, again, this is also a valid line with positive slope, but again, 1 single point of intersection. As you keep drawing, bache, you will come to a stage where the line will become tangent to my curve. Where the line will become tangent to my curve. And in that situation, there will be how many solutions? So, 1 solution here, 1 solution here, but in this case, there will be 2 solutions. When the line becomes tangent, there are 2 solutions. And the moment you go beyond it, the moment you go beyond tangency, what do you get? Look at this. 1, 2, 3. 3 distinct solutions. Anywhere you draw the line which is beyond the tangent, it will continue cutting my mod log graph at 3 distinct points. So if I want P for which f equal to g has 3 distinct intersection points, that means my slope P has to be lesser than the slope of my tangent line. Yes or no? Yes or no? Let me draw just this much part of the line in the first quadrant, as it is the part of the line in the third quadrant is of no relevance to me. So I'll draw this again to you and make you understand what I am saying actually. See, there are two situations, no? One, you consider this blue line. Just consider this blue line and you will realize what I'm saying. So this is a blue line which is tangent to my curve, cutting my mod log, my f graph at two distinct points. And then you draw, let's say this line. You can very clearly see, bache, this is intersecting at two distinct points and this is intersecting at three distinct points. I want three distinct points. So yellow line is what is of interest to me. And please observe, the tangent, let's say, has angle of inclination theta 1, and the line below the tangent line, the yellow line, let's say, has angle of inclination theta 2. You can clearly see theta 2 is less than theta 1 and both are acute angles. My P is positive. Both are acute angles. That means both are sandwiched between 0 and pi by 2, and tan in 0 and pi by 2 is a strictly increasing function. So you will get tan theta 2 is less than tan theta 1. It's a strictly increasing function, so it's a 1-1 function. Tan theta 2 means slope of the yellow line, which is my line of interest because it is cutting my f, the graph of f at three distinct points. It is less than the slope of tangent line, which is the blue line. So what will I do if I want to find out what is the range of P? I first need to compute the slope of the tangent line. Any slope strictly less than the slope of the tangent line will give me a line which will cut my graph, my mod log graph at three distinct points. Are you understanding? Whatever is the slope of the tangent line, I take the slope strictly lesser than that. Any slope value strictly lesser than that and draw a line y equal to px with that p slope. It will continue intersecting my mod log x graph at three distinct points. Okay, so I first need the slope of the tangent line. So understand the tangent line. It is a tangent, let's say at point P. Let's say the coordinates are x comma f of x. Now see, when you draw this graph, the mod log x graph, as I told you, this branch has definition log x, this branch is definition minus log x. So your point P, the point of tangency, is sitting on the log x branch, not minus log x branch. Your point P is sitting on the log x branch. So if you want the slope of the tangent at P, what is it? D by dx of log x, not d by dx of minus log x, d by dx of log x at P, which means 1 by x at P, which is nothing but 1 by x, because P is x comma f of x. But you also realize that what? My curve is log x on which P is sitting, which is the point of tangency, and the tangent line is actually passing through origin as well as point P. Origin as well as point P. So how can I write the slope of the tangent line when I have 2 points on it known? Using the 2-point form, y2 minus y1 upon x2 minus x1. So f of x minus 0 upon x minus 0. F of x minus 0 upon x minus 0. This is also the slope. So 1 by x I have computed as the slope of the tangent line with respect to the derivative approach. And f of x by x, this is the slope again of the tangent line, but I have computed using the 2-point form. Both of them are equal. X is positive. Why is x positive? Because I told you P is sitting as the point of tangency on the log x branch, right? And that is corresponding to x greater than 1. So x is pakka positive. This x cancels out. You are left with f of x equal to 1, which means log x equal to 1, which means x is E. When x is E, y is 1. That means your point of tangency, bache, is E comma 1. And what is the slope of tangent at E comma 1? Slope of tangent at E comma 1 is 1 by x at E comma 1, which is 1 by E, right? That's the slope of the tangent line. So my P slope has to be strictly less than 1 by E, and I told you it can't be negative, it can't be 0, it has to be positive. So anywhere in this range, if you pick up P, your g of x, which is y equal to p of x, is going to cut my f of x at 3 distinct points. Such an interesting question. Such an interesting question. So you started drawing lines y equal to p of x. Initially it was intersecting only once. Then slowly you kept on drawing till the time it became a tangent where it was intersecting twice. And then beyond it, you go slightly also beyond it, it will start intersecting thrice. And then forever it will intersect thrice only. So that means when is it intersecting thrice? When the slope is strictly less than the slope of the tangent. Okay, is it cool? Interesting question, right? Beautiful analysis involved. I loved this question. I hope you understood it. If yes, drop down hashtag HDCC right now. I'm looking at the chat. Drop down hashtag HDCC. Is this clear? You can get this question in multiple forms, bache. The approach should be clear. The visualization should be clear. The idea that I've used should be absolutely clear. How am I thinking? Please understand that. How is ma'am thinking? How is ma'am connecting the dots? How is ma'am actually keeping the previous data in head and then figuring out what she has to do next? So all my thought process, my thinking strategy, try to grab that as well. And of course, I'm explaining you the entire post-mortem of what the question is trying to say. What is it demanding from you? How can you crack it? More than about solving arithmetically, this was observing analytically. So this is a type of question where students get trapped. So I don't want my students to get trapped. Is that cool? Yes? Awesome. Awesome. Then let's go to the next question. P belongs to 0, 1 by E. Cool. The next question which I'm going to show you is beautiful. It is really, really, really going to help you amp up your game. So make sure you are focused and super attentive. Look at this. It's a 2021 PYQ. The question is beautiful, again based upon transformation of graphs. See people, transformation of graphs is something which many students take for granted, and I really, really want to give you a disclaimer here. Transformation of functions is a topic which you study in the chapter functions. I agree. But it is one topic which is drastically to okay, dramatically important for other units as well. Because of how the concepts are being intertwined now in the JEE Main questions, you have to realize until and unless your visual apparatus is not oiled and serviced, you can't expect to crack questions of JEE Main and cross that 99 percentile barrier. You just can't. You have to polish your visual apparatus. You have to work on imagining stuff. You have to service your visual apparatus, properly oil your visual apparatus so that when you sit in the examination hall on the D-Day, you're able to visualize things, you're able to transform functions, you're able to vertically shift the functions upward or downward, horizontally shift the functions left or right. You can stretch them, you can contract them, you can flip them. You can take modular transformations of them. Whatever is required, all the playing around graphs, whatever is the demand of the question, you are able to do that. That is why whenever I come with questions to you, if it's an algebraic question where it involves a lot of calculation heavy stuff, that is a different approach. But whenever I come with questions which demand some amount of imagination, visualization, I always emphasize upon being able to see what the question is saying. When you are able to see what the question is saying, you are able to feel what the question is saying. And it's very easy for you to then understand the approach to crack that question also. Because it's there in your head, and the picture is there. You've imagined it, you visualized it. So the chances of you now going wrong in the question get minimized, almost zero. Okay, so please make sure before you are attacking questions, your visual apparatus, the oiling is done properly, servicing is done properly, you have very nicely polished it so that it doesn't ditch you when you actually sit and attempt questions. This should work very fine because once you visualize correctly the question, what is it trying to say, what is it making you think, the picture is completely clear, you're able to feel the question. And that is when the connect of you with the question gets enhanced. And that is when your chances of committing errors in the question, chances of you getting to the wrong answer, chances of you applying the wrong approach minimize drastically. Okay? All right, come to this question. F of x is a piecewise defined function and g of x is mod of f of x plus f of mod x. Again, two types of transformations required here. Two types of transformations. So first of all, I'll work with f of mod x. Then we're going to work with mod of f of x. So it's just your choice. Let me see. Let me see what works for us. F of x is -1 when -2 less than equal to x less than 0 and x square -1 0 less than equal to x less than equal to 2. Yes ma'am, no ma'am. Right now, what is f of x? How does it look like? Okay, let's start. How does f of x look like? Okay, x square minus 1. When you talk about x square minus 1, well, y equal to x square is an upward opening parabola having vertex at origin. When you say x square minus 1, you pull the graph down by 1 unit. So just imagine this is y equal to x square, and when you pull it down by 1 unit, the vertex from 0, 0 comes down to 0, minus 1. This is x square minus 1. So you have performed vertical shift in the downward direction by 1 unit. Vertical shift in the downward direction by 1 unit. So you know how does the graph of x square minus 1 look like. That though you know. That much you know. But that graph only I have to draw corresponding to x lying between 0 and 2. So I will only draw it like this. Only this much. Complete x square minus 1 graph, you know it's an upward opening parabola with vertex at 0, minus 1. But I only and only need the trace of the graph corresponding to non-negative x-axis, that too from 0 to 2. That's it. So understand, please understand. Let me draw it like this. Okay. Let's say this is 2, this is 0. At 0, this is minus 1. At 2, what is the value? 2 square 4, 4 minus 1, 3. All right. Before 0 till minus 2, the value is minus 1. Minus 1 is the value. Okay, okay. This is minus 2. Guys, this is my f of x. From 0 to 2, this is still 2, right? Okay, and this is still minus 2. From 0 to 2, it's an upward opening parabola's part, x square minus 1's part, one branch, right hand side branch. And from minus 2 to 0, it's the straight line y equal to minus 1. This is my f of x. This is my f of x. Now, what I need is, I want to compute f of mod x. What is f of mod x, ma'am? This is f of x when x is non-negative, and it is f of minus x when x is negative. Tell me. Quickly tell me. F of x when x is non-negative. So corresponding to the non-negative x-axis, you have to keep the graph of f as it is. But corresponding to the negative x-axis, you have to take the image of what is on the right of the y-axis and bring it to the left. Did you understand? When you say f of minus x, it means mirror image with respect to y-axis. So whatever is on the right of y-axis, keep it as it is. Whatever is on the left, you ignore it, delete it, reject it, and whatever is on the right, you take its mirror image and bring it on the left. That is your f of mod x. So how will f of mod x look like? Very simple now. What is on the right? What is on the right of the y-axis? This part is on the right of the y-axis. This complete part is on the right of the y-axis. So I will bring it as it is. This is the part on the right of the y-axis. I have brought it as it is. See, on the right of the y-axis. What is on the left? What is on the left? I don't care. I will reject it. And what is on the right? I will take its mirror image on the left. I will just take its mirror image on the left. This is minus 2, 2, 0, and this is 3. Can you see this? I'll just... So whatever was on the right of f, whatever was on the right of f, I have kept it intact as it is. Here in this diagram, I've kept it intact. But what was on the left here, I have rejected that, ignored that. And what is on the right, I have taken its mirror image about the y-axis. This is my bache f of mod x. F of mod x is done. Now it's time for mod of f of x. What is mod of f of x? Again, just remember the definition. It is f of x whenever f of x is non-negative, and it is minus of f of x whenever f of x is negative. So whenever x is non-negative, your graph of f is kept intact, and when the graph is below the x-axis, you vertically flip it about the x-axis and bring it above. So how will this look like? Whatever is above the x-axis as it is. So whatever is above the x-axis, it's as it is. Whatever is above the x-axis, it's as it is. But whatever is below will come above. Okay, so this is 3. Whatever is below will come above, and it will look like this. This is minus 2. This is 1 and of course this is 3. This is also 1. Please check this. Did you see this? Did you realize? See, this much part is above the x-axis, so I have not disturbed. The part of f which is above the x-axis, I have not disturbed it. But the part which is below, that means this part, which I am right now marking with zigzag in white, and this part. This complete part will be vertically flipping up about the x-axis and going above the x-axis. This is what it looks like. Okay, is that cool? Is that cool? This is your what? This is your what? F of x mod of f of x. Now, please understand one thing before I move on to adding them, because that is what G is. G is demanding from me to add them. Please realize, understand the definition properly. This part is x square minus 1. This part is also x square minus 1. Basically, my f of mod x is coming out to be nothing but x square minus 1. And that's just a coincidence. There is no conclusive theory which you can derive from here. But here in this case, f of mod x has what definition? X square minus 1 throughout minus 2 to 2 interval. It is x square minus 1 only. But please understand, what about mod of f of x? See, this much part is x square minus 1. For sure. But this much part is 1 minus x square. Can you see this? Because it was x square minus 1 before this part, but I have flipped it above. So it will be minus of x square minus 1, which is 1 minus x square. And this part is what? 1. Okay. So from 0 to 1, it is 1 minus x square. From 1 to 2, it is x square minus 1. And from minus 2 to 0, it is y equal to 1. Please remember this. So that when I am computing my g of x, it is nothing but mod of f of x plus f of mod x. And I will be dividing my function into 3 regions because the definition is changing in these 3 regions. I have x greater than equal to minus 2 less than 0, then x between 0 and 1, and then x between 1 and 2. Let's go. Mod of f of x is 1. F of mod x is nothing but x square minus 1. That is, so throughout x square minus 1, this gets cancelled out. You're left with x square. Between 0 and 1, this is 1 minus x square, and f of mod x is x square minus 1. Cancel. This is 0. Between 1 and 2, this is x square minus 1. And that is also x square minus 1. So this gives you 2x square minus 2. Cool. So my g function is sorted. G function is beautifully sorted. What is it? G function is beautifully sorted. It is x square when this happens. Then it is 0 when this happens. And it is 2x square minus 2 when x is lying between 1 and 2. Question says in the interval minus 2 to 2, open interval, where all is g differentiable, not differentiable. Options are not continuous, not differentiable at one point, not differentiable at 2 points, differentiable at all points. Can I say it's not continuous? Let's check the continuity. I am only concerned with the continuity at the connecting points, correct? So at 0, left hand limit is obviously 0, right hand limit is also 0, value of the function at 0 is also 0, so continuous at 0. What about at 1? Left hand limit is 0, right hand limit is again 0, and value of the function at 1 is also 0. So this is continuous at 1 also. So if I talk about in the open interval minus 2, 2, this is continuous everywhere. Your G is continuous for all x lying in minus 2, 2 open interval. But what about it being differentiable or not? What about the fact that where is it differentiable? So you compute g dash x. This will give you 2x, 0 and 4x. Okay, this is when minus 2 less than equal to x less than 0, x greater than equal to 0 less than 1, and x lying between 1 and 2. Clearly check, bache, at 0, g dash of 0 from the negative is 0 and g dash of 0 from the positive is again 0. But at 1, what is the scenario? G dash of 1 from the negative is 0 and g dash of 1 from the positive is 4 into 1, 4. This is to chalo equal. This is unequal. So my g is differentiable at 0 but not at 1, which means I can say g is differentiable in minus 2 to open interval except at 1. See, g is differentiable everywhere in the interval minus 2 to except at 1. G is differentiable everywhere in minus 2 to open interval except at 1. It's continuous everywhere. It's continuous everywhere. Okay, so not continuous, that is wrong. Not differentiable at 1 point, that is correct. Not differentiable at 2 points, no. Differentiable at all points, no. So the right answer is option B. Is that clear? Did you like the question? I mean, I loved the question. I loved the question. Even when this was asked in the paper, I have loved this question, how they have incorporated the idea of transformation of graph, and then they have demanded from us that you transform f into mod f and f of mod x. And then you add all of them. You add both of them, and then the new function which is formed, now you compute its differentiability and continuity, all that analysis now you do. Such a beautiful blend of concepts, and that is why I want you to please stay attentive in all the questions which I'm discussing. These are really important questions, and as I always say, the questions which I'm discussing, each one of them is representing a variety. So the concept understanding, the approach understanding is non-negotiable over there. You have to take away the thought process, the idea, the soul, the approach of that question, the how and the why of that question. Number 2, we are post-morteming the question, every question. So how much ever we unlayer, those many concepts start coming on the surface, and that is how rich our revision becomes. Understanding? So when you start, at every step, you start asking why this happening, what if this doesn't happen, why do we need to attach this condition, what is happening in the next step, why is this necessary, why can't we do that? So much of postmortem when you do at every step. Just imagine so much of learning happens on the way, and that is why question solving, correct set of question solving is the best revision strategy. When you solve the correct set of questions in the right way, with the right mindset, with the right goal in your head, there's no better revision strategy than this. There is just no better revision strategy than solving the right set of questions with the right mindset and the right approach, like we are learning in this marathon. Alrighty then, let's go to the next question, everyone. B is the right answer here. Coming up next, what is this? What do you feel? Read the question. For which of the following ordered pairs mu comma delta, the system of linear equations is inconsistent? You remember I have taught this to you. Do you remember or no? When we were studying matrices and determinants one shot, I had told you this beautiful shortcut wherein you don't have to use the Cramer's rule. You actually can treat each of these equations as a plane. You can treat each of these equations as a plane, and then you know how you have to study the interaction of the planes using the concept of family of planes, and then you can very easily visualize and conclude about no solution, unique solution, infinitely many solutions, whatever. Remember that shortcut? I had taught this to you in the session of matrices and determinants. Do you remember that shortcut? Huh? Don't use Cramer's rule. Don't compute del 1, del 2, del 3. No. When you say inconsistent, first of all, this means no solution. What is the scenario of no solution? Please understand. I am asking you that you take x plus 2y plus 3z equal to 1, 3x plus 4y plus 5z equal to mu, 4x plus 4y plus 4z equal to delta. Take each of these equations as representation of 3 planes, guys. You have to understand Cramer's rule is very lengthy, and the shortcut which I'm about to discuss is very important, very nice, very handy, big time saver, very big time saver, and a guaranteed solution giver. Guaranteed solution giver. Here, what do? We have to understand how planes interact with each other to give us either a unique solution, infinitely many solutions, or no solution. See, imagine you have a wall in front of you. Not imagine, wherever you'll be sitting, there is a wall in front of you. There is a wall adjacent to it, and there is the floor. The wall in front, the wall adjacent, and the wall below, basically the floor, all these 3 are intersecting at a common corner point. It's like 3 planes are having a unique solution. There is just one one point which is sitting commonly in the three planes. That is how the three planes actually interact with one another to give you one unique solution. Next, if you talk about no solution, this means either all the three planes are parallel, or two are parallel, one is intersecting like a transversal, or the three are sitting in a triangular fashion. Imagine these two and third is here. Imagine these two and third is here. So obviously there is no point common in them. There is no solution. This is how they arrange when they have to produce no solution. Last is infinitely many solutions. Infinitely many solutions is very simple. Suppose two or all three planes are coincident, or two are coincident and one is cutting them like a transversal. In that case, there is a line produced which is common in all the three planes, and the points sitting on that line are infinitely many points and hence infinitely many solutions, right? Or you can say there are two planes intersecting on a line and the third plane is passing through the line of intersection of two planes. Again, there will be a line in common and there are infinitely many points sitting on a line, so infinitely many solutions. Understanding my point? Are you understanding my point? So this is how you have to visualize how planes interact to give us unique solution, no solution, or infinitely many solutions. Clear? Here you can see it's a non-homogeneous system. Okay, it's a non-homogeneous system. What do I do in order to apply the shortcut? One second, yeah. In order to apply the shortcut, I will use the concept of family of planes. You know, A times P1 plus B times P2 equal to P3. What does this mean? This is one of the linear combinations of P1 and P2 which is equal to P3. This means P3 is passing through the line of intersection of P1 and P2. This is what it means, right? I know planes is not in your syllabus, but at least this much fundamental understanding you should keep if you want to apply the shortcut and save your time. And I know you should. Okay, you have to. So, what do you think you will do? What do you think you will do in order to create a linear combination, of any of the two planes in the picture? You have three planes. You somehow have to create a linear combination of any two planes such that it is comparable with the third plane. That's the idea. The trick is create a linear combination of any two planes, combine them in some or the other fashion so that it is comparable to the leftover plane. Tell me, think. Any clue? Think, yes. Quick. If I say P2 minus P1, 3x minus x gives you 2x, this gives you 2y, this gives you 2z equal to mu minus 1. And P3 is what? 4x plus 4y plus 4z. So I can take 2 common. I will have 2x plus 2y plus 2z equal to delta by 2. Can you see P2 minus P1 is actually a linear combination of P1 and P2. 1 times P2 plus minus 1 times P1. So I have combined P1 and P2 using a linear combination so that you can see the DRs. The DRs are actually matching with the DRs of P3. That means both these are actually parallel planes. The DRs are common, same exact photocopy. So they both are parallel planes, but parallel has two meanings, guys. One is parallel with a positive distance between them, which means no solution. Another is parallel, which is coincident. So infinitely many solutions. So do they have positive distance between them or do they have the distance 0 between them, which means they are coincident? That is determined by the right hand side constants. Please understand this. If I say mu minus 1 is equal to delta by 2, this would imply both the planes are actually photocopy of each other, so they are coincident and hence infinitely many solutions. Whereas if I say my right hand side constants are unequal, that means they both are parallel because the DRs are same, but there is a positive distance between them and hence there is no solution. This implies no solution. I want inconsistent system, which means I want no solution. So this is my scenario. And which ordered pair supports this? See, mu comma delta is the ordered pair. Now, what should I put as mu and what should I put as delta out of the given 4 options such that it supports my no solution condition? I believe it's option C, because when I put mu as 4, I get left hand side as 3 and delta as 3. I get right hand side as 3 by 2. 3 is not equal to 3 by 2. But if you plug in anything else, my left hand side will come out to be equal to right hand side. Suppose you plug in 4, 4 minus 1 is 3, 6 upon 2 is again 3, equal. Next is 3, 3 minus 1 is 2, 4 upon 2 is again 2, again equal. If you plug in this as 1, yeah, okay, again 0, 0. That means only C option, the ordered pair sitting in C option, is supporting my condition of no solution. So corresponding to mu 4 and delta 3, I will have no solution. So because I was explaining here, I believe you would have thought ma'am is taking so much time, but actually when you apply the shortcut, which I told you right now, that treat the equations like planes and try to come up with a linear combination combining any two planes so that it is then comparable with the leftover plane. And then depending upon what you want infinitely many solution or unique or no solution, you can put the restriction on the right hand side constants and compare the DRs as well. And that will give you your answer. If your imagination is working well, if your visualization is working well, you've understood how geometrically planes interact to give you unique solution, no solution, and infinitely many solutions, applying the shortcut here is going to be very simple and very big advantage which you're going to have over your competitors. All right. I hope this question is absolutely clear. Hashtag HDCC everyone. I'm looking at the chat. Quickly flood the chat with hashtag HDCC. It's clear. Absolutely clear. Look at the solution once more. Try to absorb what we did. Try to see if it's sunk in or not. Quickly. All good? Digested everything? Let's go. Let's go. This is a very famous question, a very common question, and I know you know how to solve it. I have solved it in my matrices session with an even bigger number, but here I wanted to give you the idea. I have told you already that when you want to compute number of 3 cross 3 matrices A with entries coming from this set such that the sum of the diagonal elements of AA transpose is 3 or 9 or whatever, what do you do? What do? You first of all decode that sum of diagonal elements of AA transpose is nothing but trace of AA transpose. And I had taught you to remember the value of trace of AA transpose. Do you remember? Do you remember? Tell me, do you remember? If I take A as A, B, C, D, E, F, G, H, I. Yeah, A transpose as A, B, C, D, E, F, G, H, I. Then when you compute AA transpose, what will be the diagonal entries? First row into first column, A square plus B square plus C square, D square plus E square plus F square, G square plus H square plus I square. I don't care what other entries are. I am interested in the trace of AA transpose, which means I'm only interested in adding the diagonal entries. I am only interested in adding the diagonal entries, right? So I only need to compute the diagonal entries, and this is what I wanted you to remember. Trace of AA transpose, guys, please remember this is A square plus B square plus C square plus D square plus E square plus F square plus G square plus H square plus I square. This is what you want. 3, keeping in mind that your A, B, C, D, E, F, G, H, I is coming from the set -1, 0, 1. From here, you have to start the question. There is no need to do all this. Now you should be well versed and you should have obtained the perfection of directly starting your question from this step. And in your mind, it should be clear that A, B, C, D, E, F, G, H, I are actually my entries of set A, which are coming from -1, 0, 1 set. And this is the trace which I have to equate with 3. So let's start with the case 1. Let's start with case 1. You have 9 entries, A, B, C, D, E, F, G, H, I. Out of the 9 entries, if any 3 become equal to 1, you will get 1 square plus 1 square plus 1 square, which is 3. And whatever 6 leftover entries are there, take them 0. Your answer will come out to be 3 every time. In how many ways can this happen? 9 factorial upon 3 factorial into 6 factorial. Case 2, similarly, because I have -1, 0, 1 as the entries available, I can take any 3 entries as, let's say, -1. Minus 1 square plus minus 1 square plus minus 1 square will give me again 3, no? And whatever 6 entries are left, take them 0. Again, you will get the sum 3. So 9 factorial upon 3 factorial into 6 factorial. Case 3. If you take any 2 entries as 1 and out of the 7, you take any 1 as minus 1 and whatever remaining 6 are there, you take it to be 0. Again, you will get 3, isn't it? So 3 entries you've picked up, 2 you've kept as 1 and 1 you've kept as minus 1. 1 square is 1, 1 square is 1, minus 1 square is also 1, sum is 3, rest all are 0. 0 square is 0. Correct? So this, how many ways? 9 factorial upon 2 factorial, 7 factorial into 7. And there is a case 4 as well, which has come from case 3 only. Out of 9, any 2 entries you take as minus 1 and out of the 7, any 1 you take as 1 and the remaining 6, all you take to be 0. So the value is the same, 9 factorial upon 2 factorial, 7 factorial into 7. Did you understand? Did you understand? Yes, there are no more cases, people. You can realize this. 3 ones, rest 0. 3 minus 1s, rest 0. 2 ones, 1 minus 1, rest zeros. 2 minus 1s, 1, 1, rest 0. Okay? This number comes out to be 84. This also comes out to be 84. This comes out to be, you can check, 252. This also comes out to be 252. When you add all of them, you get 672 as your final answer. Everyone, please tell me if this is understood. In place of 3, you can have a 9, you can have a 6, whatever number supports, you can get that number. It's not a compulsion, you will get 3 only. But how are we making the cases? How are we applying the permutation concept over here? Especially the combination concept, NCR formula, how are we applying and how are we actually computing the cases in such a way that no case is left behind. No case is missed out here. All the cases are covered. This is the only tricky part of this question. Otherwise, the question is very simple. Literally, it's very simple. Solving factorials, adding the numbers, that is the arithmetic part. That is the childish part. But the conceptual part, if I have to talk about, the question is easy. The only slippery area is don't miss out on even a single case. Please don't. Is that clear? Are we on the same page, everyone? All the questions you're absorbing till now? Any confusion, any doubt? Tell me quickly, because we are attacking one of the toughest questions of JEE Main. This is most interesting. I have a big smile on my face. Most interesting and one of the toughest questions asked in JEE Main. And I will also tell you there is a flaw in this question. If you can identify, do that, but I will also tell you that there is a flaw in this question. And that flaw actually is a big one. Why is it a big one? Tell me. The flaw is a big one. Can you crack the question? Can you tell me the approach? Can you tell me the approach? Can you tell me the approach? Think about it. When I say it's one of the most interesting questions, that doesn't mean it is something which is a bouncer. No. When I say interesting, it means the concept uses something that you know, but it's being applied in a very beautiful way. And because many students were not able to do that, they rated the question as one of the toughest questions. Tell me. Yes? Okay. See, what is the question saying? F of a plus b plus 1 minus x is equal to f of x for every x. This is a relationship which is given to us. Very, very important functional equation which is being said to be true for all x. It is being said to be true for all x. Yes or no? Yes or no? What will you do next? You are given that 1 upon a plus b. Look at the integral that you are given. 1 upon a plus b integral a to b x into f of x plus f of x plus 1 dx. Correct? Correct? F of x plus 1 dx. Okay, fine. That means f of x to chalo I have. What about f of x plus 1? Now comes the trickiest part of the question. In this equation, if you substitute x with x plus 1, is it valid? Yes, ma'am, it's valid, because if x is real, x plus 1 is also real. And for every real input x, this equation is holding true. So for x plus 1 also it will hold true. This is the tricky part, guys. This is the tricky part. So f of a plus b plus 1 minus of x plus 1 is equal to f of x plus 1. So you are getting f of a plus b plus 1 minus x minus 1. So you get a plus b minus x. A plus b minus x is equals to f of x plus 1. So now you have f of x with you, you have f of x plus 1 with you. Can you tell me what will you do next? Look at the integral. No, I is given to you. I is 1 upon a plus b integral a to b x times f of x plus f of x plus 1 dx. All right. Now, because I know what is f of x plus 1, let me write it down. A to b x times f of x plus, what is f of x plus 1? We just saw it is f of a plus b minus x. F of a plus b minus x dx. This, let's take this as equation number 1. And now I want you to apply something which somewhere this expression is itself giving you a hint of. Somewhere this expression is itself giving you a hint of it, and that is none other than, yes, you're right, the King's rule. The King's rule. It's the King's rule. So I is equal to 1 upon a plus b integral a to b. X will be replaced with a plus b minus x. Inside you will have f of a plus b minus x plus, what about this? This part, when you replace a plus b minus x here, when you replace x with a plus b minus x, what are you getting? A plus b minus a minus b plus x. Cancel, cancel. So just left with x. That means here I will get f of x dx. This is 2. Is this clear? I have done nothing. First equation, applied King's rule. Second equation. You can clearly see, bache, f of x plus f of a plus b minus x. F of x plus f of a plus b minus x. This will be coming out common, and I will be just left with x plus this when I add both the equations. So add both the equations, 1 plus 2. You get 2i equal to 1 upon a plus b integral from a to b. Next, your f of x plus f of a plus b minus x. This is to chalo common. And inside what are you left with? What are you left with? X plus a plus b minus x. X plus a plus b minus x. This cancels out, and eventually you're left with a plus b, this a plus b, and this a plus b also cancels out. So you are just left with 2i is equal to integral a to b f of x dx plus integral a to b f of a plus b minus x dx. Guys, just tell me one thing. Tell me one thing. Please tell me one thing. This integral, can I say this is equal to integral a to b f of a plus b minus a minus b plus x? I am applying the King's rule. So eventually I will just be left with this. Can I say this integral, this part of the integral is equal to integral a to b f of x dx? Yes, because I have applied the King's rule. Very true. Integral a to b f of x dx is same as integral a to b f of a plus b minus x dx. Very true. That means eventually I am getting 2i is equal to integral a to b f of x plus integral a to b f of x. So twice integral a to b f of x dx. Wow, 2 cancels out and I have the value of my integral a to b f of x dx. Problem, screaming out loud. No option out of A, B, C, D is matching with this. We have put in so much of hard work to kind of resolve the value of I and bring it in a standard integral format. We have been successful to do so as well. But the problem is that it's not matching any of my options. Okay, what to do? What is my I? It is integral a to b f of x dx. What do you think I should do? What do you think I should do? Think, no? Somehow I have to make it match with some of the option. No, at least one option. What? At least one option is JEE Main. What is that one option which actually matches with I? Now there are 2 approaches. I'll tell you 2 approaches. One approach is, see, using the King's rule, you have I is equal to integral a to b f of x dx. Using the King's rule, you can say I is equal to a to b f of a plus b minus x dx. But bache, right in the beginning you had seen that f of a plus b minus x is nothing but f of x plus 1. Yes or no? Yes or no? So this is nothing but integral a to b f of x plus 1 dx. What I'm going to do is I'm going to plug in x plus 1 equal to t, so dx equal to dt. If x plus 1 is a, tell me, if x is a, t is a plus 1. And this is b plus 1 and this is f of t dt. But x and t are dummy variables. So a plus 1, b plus 1, f of x dx sitting in option A. Do you see this? This is why I was saying question is tough, because it demands from you a lot of manipulation. It demands from you a lot of presence of mind. Too much of presence of mind required. Too much of presence of mind required. Tell me. Tell me, is this cool? But that's not all. You might feel, okay, I've got option A as the correct one. Now what? That's not all, because another approach, let me tell you, bache, if you plug in x as t plus 1, dx is equal to dt, your integral becomes equal to what? A minus 1 to b minus 1, f of t plus 1 dt. Plug in t as x because they are all dummy variables, a minus 1 to b minus 1, f of x plus 1 dx. D. A is also correct, D is also correct, and that was what was the flaw in the question, that this was a JEE Main question, but it had 2 distinct options correct, which means this question was gave to students as a bonus question. So I don't know if again a situation like this arises or not, because NTA has now become super strict with its protocols and all the security schemes and everything that they are launching now. They've been super duper strict to ensure that everything is safe, secure, and the operations, examination operations are run very smooth without any mishaps at all. 100%, I have very less expectation of something like this again repeating, that it's a bonus question. But having said that, I hope the question taught you a lot. There was a lot of learning hidden in the question, and in every way possible, from every direction possible, we have tried to exploit this question and completely learn from it. We have nichodified it, isn't it? Completely. Twist and turn, proper. Okay. Is the learning done? So 2 options correct. Of course, in JEE Main, if this question is asked, 2 options won't be correct. But however the question or the options are modified, this is a very big time potential question to be there in your paper. And I want all of you all to please take a note of this, that it is a tough question, which was considered tough by students when it came. But it was very interesting. It had a tricky step of substituting x as x plus 1, and then how and when you have to bring in a new definition of f is something which requires a lot of presence of mind. A lot of presence. When do you apply the King's rule? When do you use the fact that f of a plus b minus x is f of x plus 1 only? A lot of presence of mind required. Okay? Cool? I hope you're not tired. I'm taking you to the next question, everyone. Please brace yourself. This is something which I have discussed before, but I was very keen, very interested to actually discuss it again. Can you tell me what is the answer? Anyone? Try it out. You can crack it in a minute and a half. I seriously believe this doesn't require a lot of your time. You can crack it in a minute and a half. That's it. You don't need much time. How do you think you will crack this? F of 0 is given to be 1. Why is f defined from -1 comma infinity to r? Because the function is log of 1 plus x upon x. Log of something is defined only when the input is positive. So x is greater than -1. Therefore, the domain of f is given to be -1 comma infinity. And the denominator is x, which can't be 0. Which can't be 0. Log of 1 plus x upon x can't be 0, so it's actually minus singleton 0, but that is already written over here, x not equal to 0. Cool, so everything is being taken care of. I have been asked, where is this function increasing, where is this function decreasing? But there is a very big signal given through the options. Can you see that? A very big signal is given through the options that increases in -1 comma 0, decreases in 0 comma infinity. Increases in -1 comma 0, decreases in 0 comma infinity. This option is trying to say that 0 is the point of maxima. Next, decreases in -1 comma 0, increases in 0 comma infinity, which means this option is suggesting that 0 is the point of minima. So this means at 0 there is a turn. Either a turn corresponding to 0 being maxima or a turn corresponding to 0 being minima. Option A, option D are saying there is no turn. Throughout the domain it is increasing, throughout the domain it is monotonically decreasing. So let's see if there is a turn in the graph or not, or if there is a monotonic behavior of the graph throughout its domain. Let's check, and for that I have only and only one tool, a promising, well-established tool, very rewarding, which is the derivative. And this question will amaze you, because when you compute the derivative, log of 1 plus x upon x, second function into differentiation of first, minus first into differentiation of second upon second whole square. Now the problem with this question is, I have to decide now whether f dash is positive, negative, or if it is 0, what are the critical points. The problem is, it is very difficult to determine the sign of f dash. Why? I know x square is throughout positive for all x coming from the domain of f. So denominator is sorted. But until and unless my numerator doesn't get sorted, I will not be able to comment upon what is the sign of f dash in the domain. Where is it positive? Where is it negative? Where is it 0? It's very difficult. Why? Because the numerator is a combination of the algebraic function and a logarithmic function. Whenever you are stuck in such a case where the blend of functions is such that you are unable to determine the sign as to where is it positive, where is it negative, that's not very convenient for you, no? It's not like an algebraic multiplication of factors, you know where is it positive, where is it negative, apply the wavy curve method and boom, you're done. No, it's very confusing. It's a combination of algebraic and logarithmic function. How can you possibly come out with the fact that, okay, this is positive here, negative here, 0 here? No, it's difficult to solve this, time consuming, complicated. That is when you use a trick, a hint, which is hit and trial. Hit and trial. What do you mean by hit and trial? See, your domain is -1 to infinity. And the point in question is 0. 0 being the point of max or 0 being the point of min. That's the question, no? So what you do, 0 will be a point of maxima when before 0 it's f dash is positive, after 0 f dash is negative. 0 will be a point of minima when before 0 f dash is negative, after 0 f dash is positive. That means I just need the sign of f dash in the neighborhood of 0, in the vicinity of 0. So what you do, you use hit and trial, you take a number close to 0 to the left of 0 in the domain, let's say -12. And you also take a number to the right of 0, close to 0, let's say 1. That's it. Now at 1, What is f dash? At minus half, what is f dash? Let's see. F dash 1, just the numerator. This is 1 upon 2 minus log 2. So this is 1 upon 2 minus, tell me, this is 0.5 minus 0.693. Obviously, this is negative. And if I talk about f dash minus half, this is minus half upon 1 minus half is again half. So this is minus 1, and this is plus log of 1 minus half is again half. So 2 to the power minus 1, so this is plus. So this is minus 1 plus 0.693, again this is negative. That means before 0, f dash is negative. After 0, f dash is negative. That means throughout the graph is decreasing. Before 0 decreasing, after 0 decreasing, that means 0 is neither a point of max nor a point of min. 0 is neither a point of max nor a point of min, and the graph is throughout its domain monotonically decreasing. So when you are not able to compute the sign of f dash in a complete range, in a complete interval, please pick up any one point from that interval, because that is from where your basics have come. Your basics said the same thing. Whatever is the value of derivative on one point of that interval, that same is the sign of the derivative on the entire interval. Okay, so when you are in general not able to compute the sign of f dash on an interval, please take up a point there. That's your tricky method. The trick which will help you get to the answer faster. Take any one convenient point in that interval and compute the sign of f dash on that point. Whatever is the sign of f dash on that point, same is the sign of f dash over the entire interval from where you've picked up the point. Just make sure that the point you've picked up is satisfying the domain condition. It should not go beyond the domain. Please remember this, very, very important. This question is a PYQ, but many students were not able to crack this because they just did not know that they can do such a simple thing to actually get to the answer. They just had to do this much. And where they were trapped? In the combination of algebraic and logarithmic function. So I hope this question is hashtag HTCC, everyone. Cool? Yes? Okie dokie. Moving ahead. Total number of 4-digit odd numbers which can be formed using 0, 1, 2, 3, 5, 7 and having distinct digits. So repetition is not allowed. Repetition is not allowed. Total number of 4-digit odd numbers which can be formed using 0, 1, 2, 3, 5, 7 and having distinct digits are. Tell me. How do you approach? PNC, very famous category, using the digits. Think. How will you start? It's a very small question. If you know the logic, you know the concept, it's a very small question. You can crack it in a minute max. Tell me. Think. The question is self-explanatory. Whatever it is saying, just keep adding those conditions. And very easily you can get the answer. Tell me. 4-digit odd numbers. If you want an odd number, so there is a units place, tens place, hundreds place and thousands place. If you want an odd number, bache, then in the units place, you want either a 1 or a 3 or a 7 or a 5. You want 1 or a 3 or a 5 or a 7. Correct? So if I talk about units place, it's a guarantee it can be filled in any of the 4 ways. Either by a 1 or a 3 or a 5 or a 7. Either by a 1 or a 3 or a 5 or a 7. Let's say 3 occupies this place. If 3 has occupied the units place, it can't be used in any other place because I don't want repetition of digits. Okay, so now I don't have 3 to be used in any place. If I talk about thousands place, start with the first one. No, start with the thousands place. Thousands place can't be filled with 3. 3 though is now out of the question. It's no more available because my units place is filled with 3. But apart from 3, even 0 can't come and sit in the thousands place. Right? Otherwise, my digit will be a 3-digit number. Yes, 0 can't sit, 3 can't sit. I have 1, 2, 5, 7, 4 options. Perfect. Now in one of these four options, 1, 2, 5, 7, let's say 2 sits here. Come to the hundreds place. 2 sits here. Now 3 has already been taken, 2 has already been taken. You're left with 0, 1, 5, 7. Any of these 4 can come in the hundreds place. There is no problem at all. So 4 ways. 0, 1, 5, 7. 4 ways. Any one, let's say 0 sits in the hundreds place. Let's say 0 sits in the hundreds place. Now I have just 3 options left to fill my tens place. So my tens place can be filled in 3 ways. Is this clear? So your answer is 4 ways, 4 ways, 4 ways and 3 ways. 64 into 3. 192. Easy peasy lemon squeezy. Easy peasy lemon squeezy. Is that cool? Did you understand the approach? If at all you are not able to visualize that, okay, what numbers will come, how many ways can this place be filled, how many ways can this place be filled, put a number. Always it is advisable, put a number. If you know units place can be filled in 4 ways, pick up any one of those 4 ways and fill the units place. Fill the units place with that number and now start analyzing the scenario. You will never ever commit a mistake in questions like these. Fill the units place, no. Next, fill the thousands place, no. Next, fill the hundreds place, no. Once you keep filling, then you exactly know how many ways are left, how many numbers are left, and how many ways can you fill the remaining blank spaces. Okay, so keep filling. It's a very beautiful shortcut coming from someone who has applied it, because I didn't want to miss out on even a single case. So I used to do this. If units place can be filled in 4 ways, take one of the numbers and fill the units place and then start analyzing the scenario. Okay, cool. I hope this is clear. Very easy peasy lemon squeezy question from PNC. I hope the logic is clear, the understanding is clear, and how have we solved the question. That approach and flow is also very clear. Hashtag HDCC. Come to this conceptual question from quadratic equations. Now, quadratic equations is something which is a big strength for a lot of students. It is a big strength for, I think, almost every student. But this is how a question tests your conceptual understanding. See, 2a plus b plus c is 0, c is non-zero. The quadratic equation has no root in 0, 2. No root in 0, 2 means discriminant is negative. Exactly 1 root in 0, 2. Both roots in 0, 2. Exactly 1 root in 0, 1. How do you think? How do you think you should approach this question? Tell me. How do you think you should approach this question? Quick, think. How do you think you should approach this question? We don't know anything about ABC. There is a relationship being satisfied between A, B and C. 2a plus b plus c is 0. Otherwise, it's written ax square plus bx plus c is 0. It's a quadratic equation, but A, I don't know. It can be positive or it can be negative. If it is positive, upward opening. If it's negative, downward opening. Now see, exactly 1 root or both roots. What all situations can arise? Please activate your visual apparatus. Switch it on. Visual apparatus, guys, switch it on. If you want exactly 1 root in 0, 2, let's say here is 0, here is 2, exactly 1 root. Or it can happen, this is 0, this is 2, exactly 1 root. Similarly, it can happen in the downward direction also, no? What is the problem? What is the problem? Here is 0, here is 2, exactly 1 root. Or like this, when here is 0 somewhere, here is 2, exactly 1 root. Right? If you want both roots between 0 and 2, like this, or 0, 2, both roots between 0 and 2, like this. Can you see? So 1 root between 0 and 2. Can you see this? 1 root between 0 and 2. Both roots between 0 and 2. Yes, ma'am? No, ma'am? 1 root between 0 and 2. Both roots between 0 and 2. Visually, you have imagined the scene. Visually, you have imagined the scene. So what are you going to do now? Visually, you have imagined the scene. So what are you going to do now? Do you understand one thing? When you say there is exactly one root between 0 and 2, at 0 the sign is positive, function's value is positive, at 2 it's negative. So product of values at 0 and 2 is negative. Here also at 0 negative, at 2 positive, so the product is negative. Here also at 0 it's negative, at 2 it's positive, so product is negative. Here also at 2 it's negative, at 0 it's positive, so product is negative. That means one root implies f of 0 into f of 2 is negative. Why? Because the sign of the function's value at 0 and 2 is opposite. Similarly, if you say both roots are between 0 and 2. Okay, exactly one root in 0 and 2, both roots are between 0 and 2. If you say both roots are between 0 and 2, that means what? At 0 the sign is positive, at 2 the sign is positive, at 0 the sign is negative, at 2 the sign is negative. That means the product of f of 0 and f of 2 is actually positive. So all I'm trying to say is that the concept of location of roots is coming into action. Even if you don't know the theory of it, the fancy technical content of it, it's very but obvious for you to imagine these situations and then come up with the condition that if f of 0 and f of 2 are of opposite signs, that means I have one root. If f of 0 and f of 2 are of same sign, that means I have both roots between 0 and 2. Is that making sense? So everything depends upon the value of my quadratic polynomial at 0 and 2. Okay? See, f of 0 is what? F of 0 is c. C I know is a non-zero quantity. What about f of 2? F of 2 is 4a plus 2b plus c. But wait, 2a plus b, let's take 2 common, 2a plus b, this is plus c. 2a plus b is nothing but minus c. So you are getting minus 2c plus c, which is equal to minus c. Arey Baba, if c is non-zero, minus c is also non-zero, and c and minus c are opposite to each other. No, if c is positive, minus c is negative. If c is negative, minus c is positive. That means the sign of f of 0 and f of 2 is opposite to each other. So you are trying to say that f of 0 into f of 2 is actually negative. What you are trying to say is f of 0 into f of 2 is actually negative. Is that making sense? F of 0 into f of 2 is actually negative. When it's actually negative means there is exactly one real root between 0 and 2. It can be an upward opening or a downward opening, I don't care. So out of these scenarios, either this situation can hold true, or this situation, or this situation, or this situation. This will not, this will not. Any of these 4 situations which I've marked a tick upon, those can hold true. Is that cool? Concept is clear. Concept of location of roots, but not in a very fancy theoretical bookish manner. Just switch on your visual apparatus, the visual machine which is there fitted inside, and it's working fine. Switch that on. Switch that on, guys, and try to imagine the stuff. The moment you are able to really in an excellent manner, you're able to imagine the situation, automatically the approach will keep on clicking. Automatically, you will stop struggling with the questions, and automatically your relationship with the questions will also go to the next level. Let's come to this question now. What does it say? G of x is x minus 1 to the power n upon log of cos x minus 1 to the power m. X is sandwiched between 0 and 2. M and n are integers, m positive, n positive. P be the left-hand derivative of mod x minus 1 at 1. Limit of g of x at 1 is p. Then what is the value of m and n? This, guys, is, let me tell you, this is a JEE advanced PYQ. I have never ever said I'll only be bringing JEE Main PYQs. I never said that. I never said that. Never ever did I say that. Especially for math, it is compulsory for you to even crack advanced PYQs. Practice them. Understand them. Understand how the question is layered, and using what all concepts can you actually decode it. Try it out. Alrighty. Could you figure it out? Huh? Any idea, any clue, any guesses? It's a fantastic question, people. Very beautiful. It's a mixture of many wonderful concepts which are very much loved in, which are favorites of a JEE Main. So understand here, g of x is, what is it saying? Understand, okay? It's very interesting to decode what it's actually saying. Cos of x minus 1 to the power m, alrighty, 0 less than x less than 2. Guys, what am I interested in? I am interested in limit x tends to 1 of g of x. This is given to me as p. Can I somehow simplify my g of x? See, limit x tends to 1 of g of x. G of x is x minus 1 to the power n whole upon log of cos of x minus 1 to the power m. It's this, na? Log of cos of x minus 1 to the power m. It's this only. And I know as a matter of fact that m can jump down and come before log. Yes? So let's do that. Let's do that. This will be m times log of, just to simplify, I want to get rid of as many powers as I can, right? It will obviously make my calculation simpler. Now that I've reached here, I know when x approaches 1, this expression turns out to give me 0 by 0. Now that I have 0 by 0 with me, I'm going to use my LH rule. Why? Can I? Agreed? I can use my LH rule, right? But before I use my LH rule, there is one more step which I can perform to simplify this expression even further. And this is where a beautiful little portion of learning is hidden for you. See, always remember, I can see x minus 1 here, I can see x minus 1 here, and there is x tending to 1 here. So always in this situation, to simplify your expression even further, take x minus 1 as h. So that as x tends to 1, h tends to 0. As x tends to 1, h tends to 0. Yes? So now your limit equivalently becomes equal to what? Limit h tends to 0, h to the power n upon m times log of cos h. Again, it's 0 by 0 only. I'm not saying the 0 by 0 part will be disturbed. No, just the look of the expression will be more manageable, easier to handle. Right? Let's start. Differentiate the numerator. You will get n into h to the power n minus 1 because I'm now differentiating with respect to h. Next, m as it is, cos, log of cos h. So 1 upon cos h into minus sin h. All right, and this is limit h tends to 0. Still, this is nothing but your p only, the limit of g of x only, which was p. This is what we are getting. So n by m comes outside, limit h tends to 0, h to the power n minus 1 upon, what do you have? Sine upon cos, tan h. And with a minus sign, minus comes outside. Now what? Can you do one thing? Very interesting. Upon h into h. Standard limit. As h tends to 0, tan h by h tends to 1. So what eventually you are left with is minus n by m, limit h tends to 0 of h to the power n minus 2. That's it. This is the value of p. But the question also adds with it one more very important piece of information. P is actually the left-hand derivative of mod x minus 1 at x equals to 1. Mod x minus 1, people. Mod x minus 1, how does the graph look like? Mod x, you know, the peak is at, the vertex is at origin. Mod x minus 1. That means you shift the graph to the right by 1 unit. This is mod x minus 1. This is mod x minus 1. Remember? Mod x minus 1 is x minus 1 when x is greater than or equal to 1, and it's 1 minus x when x is less than 1. So this is x minus 1 and this is 1 minus x. Cool? Is this cool? Question says left hand derivative of this function at x minus 1. You know, if you take this as, let's say, f of x, your f dash x will be 1 when x is greater than or equal to 1 and minus 1 when x is less than 1. So f dash of 1 from the negative is minus 1, no bacha. This is your left hand derivative. Left hand derivative of your function at 1 is minus 1. Left hand derivative of your function at 1 is minus 1. That means p is minus 1. So p is given to be the left hand derivative. That means p is minus 1. P is actually minus 1. So p is minus 1 also and p is this complete quantity also. That means both these things are going to be equal. So what are you getting? Eventually you are getting minus 1 is equal to minus n by m limit h tends to 0 h to the power n minus 2. Please understand one thing. It says m is positive, n is positive. So I can say this is limit h tends to 0, minus 1 minus cancels out, h to the power n minus 2 is equal to m by n. Please understand the intricacy of this. The detailing of this, that is something which is worth appreciating. Limit h tends to 0, h to the power n minus 2 is m by n, where this quantity is non-zero finite number. This is something which is very important to identify. M upon n, it's a non-zero number, it's a finite number. When do you think limit h tends to 0, h to the power something gives you a non-zero finite number? Now the argument is starting. Limit h tends to 0, h to the power n minus 2 is actually m by n, where this is non-zero and finite. Now if you say, let's analyze. If you say n minus 2 is positive, that means n is greater than 2. If this is the scene, h tends to 0, h to the power something positive will also tend to 0, na? If h tends to 0, h to the power something positive will also tend to 0. X tends to 0, x square also tends to 0, x cube also tends to 0, x to the power 4 also tends to 0. So that means limit is 0. If n minus to the power is positive, h to the power positive will tend to 0. So m by n is nothing but 0, but that is contradiction to the fact that m by n is non-zero. So no. This can't be the case. If n minus 2 is negative, that means n is less than 2. In that case, you will have what? It will be 1 upon h to the power positive. Baba, if n minus 2 is negative, 2 minus n is positive. No. So it will be 1 upon h to the power 2 minus n. Yes or no? Huh? Yes. If h tends to 0, this thing will tend to infinity. Baba, if h to the power something is negative, that something is negative, 1 upon h to the power positive I can get. No, it's equivalent. H to the power negative or 1 upon h to the power positive. It's the same thing. Yes or no? X to the power minus 3, 1 upon x to the power 3. Correct? So if n minus 2 is negative, this thing will tend to infinity. That means m by n is infinity. No, that can't happen. If n minus 2 can't be positive, n minus 2 can't be negative, only one option is left, that n minus 2 is 0 or n is equal to 2. When n is equal to 2, only then you will get a non-zero finite limit. In this situation, you will get what? Limit h tends to 0, h to the power 0 is equal to m by n, which is nothing but 1. Yes or no? This implies m is equal to n, but n is 2, so m and n both are 2. M and n both are 2. This is a concept, guys, which not many students know. This is not something which many students know. I'll quickly write the concept for you. It actually says limit h tends to 0, h to the power n, if this is equal to non-zero and finite. This is if and only if when n itself is 0. The power has to be 0. Whatever the power is, that has to be 0. In our question, the power was n minus 2. So n minus 2 has to be 0 or n has to be 2. This is the concept. And I explained you in detail that if the power is positive, what happens? Power is negative, what happens? So there is no choice but for the power to be 0. So in a way, I've explained you the proof also, but to remember it, you can remember it like this. So this question was a fantastic question. It somehow blended the limit factor, LH rule. It has made us use this beautiful brand new result, and it also involved the concept of left-hand derivative of a mod function. Just imagine the volume here. This is a JEE Advanced PYQ which has now full potential to land in your JEE Main exam. So make sure you have understood it perfectly, beautifully and very nicely. Okay? Can you come to this question and tell me how will you solve this? Yes, it's hashtag HDCC, the previous question. Yes? It is hashtag HDCC, right? See, math questions are lengthier They are more conceptually heavy, and that is why the number of questions to be solved in the paper also on the D-Day, I always say keep it less. Keep it less in the sense I will never say that try to attempt 20, 21 questions. Keep it to 13, 14. 12 to 14 questions is a very safe range for you to target in mathematics. It will have some low-hanging fruits as well, which are very straightforward questions, can be cracked in a minute. And then you move on to the lengthier questions, which you are familiar with, you know the approach, you know how to solve them, you've practiced them drastically, too much you've practiced them. So you know that you just have to invest your 4 to 5 minutes, 6 minutes on one question and it will be done. You just need to manage your speed and accuracy. So just target a sweet spot of 12 to 14 questions and it will really help you cross that 50 mark barrier and then enter the 99 percentile club. Because the questions are lengthy, the questions are multi-conceptual, the questions are challenging in many levels. On many levels they are challenging. Okay, so don't try to keep a very unrealistic target. No, don't make it too good to be true because it won't be then and then you will be disappointed, disheartened. So please keep your target as number 1, 10 questions. When you're done with 10 questions and the time remains, then you go ahead and target another 2 questions, another 2 questions. 12 to 14 questions is where you have to ideally stop. Of course, if you know other questions, please crack them. If it's an easy paper, crack more. But in general, I am saying 12 to 14 is a safe spot for you to target. Okay? No need to rush. Too much rush will hamper your accuracy. Too much rush will lead to a lot of wasted attempts and that means waste of time. Okay? So don't rush into the math exam. Never ever ever rush into with the questions. Never rush. Attempt less questions but accurately. That plays a major role in pushing you towards 99 percentile in mathematics. Okay? Okay, chemistry and physics is pretty different. Chemistry and physics comes out to be simpler, way simpler than mathematics. So you can target around 17, 18, 19 questions in chemistry, 17, 18, 19 questions in physics, and you can even rush there. Okay, some questions are really fact-based, some questions are like you should know at the drop of a hat, your memory should have that stored. But in mathematics, a question can challenge you on multiple levels. Yes or no? You can be challenged in terms of a fact, trigonometric value of a special angle you remember or not, any concept if that's completely clear or not, visually are you very strong or not. On too many levels you can be challenged on one single question. So don't try to underestimate the dignity that math has with which it comes in the exam. Don't underestimate that and don't try to overpower it. Don't try to, play smart as to I'm going to crack 20 questions and then in between only you have messed up in 4-5 questions and you get negative marking, you fall even behind in the race. That is not something that we want. Okay? So be respectful towards the subject and plan your target in a realistic manner. Question says what? You read it, right? I've displayed the question to you. I want you to answer. I want you people to answer. If limit x tends to half, this is a, then x cube minus 3ax square minus 24a square x plus 20a has 1 real, 2 imaginary, 3 real and equal, 3 real and distinct, 2 real and equal and 1 distinct root. I want to take this question as an opportunity to explain to you how you have to visually, again see too many times I'm saying visually because math has a lot of imagining factor. How do you have to visually think about the 3 roots of a cubic polynomial? How? Please understand. If let's say the situation is something like this. Alpha, beta. Alpha is a point of max, beta is a point of min. Alpha is a point of max, beta is a point of min. The value of the function at alpha is positive. The value of the function at beta is negative. Correct? In this situation, the function has 3 distinct and real roots. It can also happen that it works something like this. This is alpha, this is beta. Alpha can be point of minima, beta can be point of maxima. I don't care. At alpha, the function's value is negative now. At beta, the function's value is positive. So basically when I say that I have 2 points of max and min, one is max, one is min, basically what I'm trying to say is the product of f of alpha and f of beta is negative. That's what I want to say. Which one is positive, which one is negative, I don't care, but they both have to be of opposite signs is what is my intention. Again, in this situation, you will have 3 real and distinct roots. Is this making sense? This is how you can imagine the setup corresponding to 3 distinct and real roots. One more thing, please remember, when your leading coefficient is 1 and it's a cubic polynomial, leading coefficient is positive. As x tends to infinity, function tends to infinity. As x tends to minus infinity, function tends to minus infinity. That means your graph is going from bottom to top infinitely. So as x tends to minus infinity, function goes to minus infinity. As x tends to infinity, function goes to infinity. So it's going like this. This is not the setup like it's going right now in the question. In the question, this is now how it's going. But in general, it can as well. I'm just explaining you a general setup right now. We will come back to the specification of the question as well. Understand the general setup. Please understand the general setup. Suppose I say I have this situation or this situation. Say this is alpha, this is beta, this is alpha, and this is beta. What do you think? F of alpha is positive or negative and f of beta is 0. This means the function has again 3 real roots but 2 repeated. Is this making sense? 3 real roots but 2 are repeated. 3 real roots but 2 are repeated. This is the situation when your conclusion is this: 3 real roots but 2 are repeated. Now, what if I say, imagine this or this. Say this is alpha, this is beta, this is alpha, this is beta. Tell me, corresponding to alpha, you have a point of max, the function's value is positive. Corresponding to beta, you have a min, again the function's value is positive. Here, corresponding to alpha, it's the point of min, function's value is negative. Corresponding to beta, it is point of max, function's value is negative. So in this case, f of alpha into f of beta is actually positive. Either both are of the same sign or both are of positive same sign or negative same sign, basically same sign. In this situation, what's happening? Only one real root, 2 imaginary. Is this making sense? Is this making sense? Only one real root, 2 imaginary roots. Let me now write or draw this figure. Let's say this or this. See what's happening. The function is strictly increasing. The function is strictly increasing. Here the function is strictly decreasing. In this case, the graph is cutting the x-axis exactly once. Yes, and it is either strictly increasing with no turns, no point of max, no point of min, or it's strictly decreasing, no point of max, no point of min. This means what? 3 real roots all equal. So distinctively, there is only one real root in this case. In this case, there is only one real root distinctively, or 3 real roots, all 3 equal, or 1 real root with multiplicity 3. But in this case, bache, only 1 real root exactly and 2 imaginary roots. On the above case, all 3 real but 2 are repeated. And in the first case, I told you, all 3 real but all 3 distinct as well. So now you know what all can be the situations, in how many ways can the graph perform or graph look like of a cubic polynomial corresponding to different scenarios of its roots. Right? Depending upon how many roots it has, what nature of the roots is, how will the graph behave. So now let's come to our function. See, it says x cube minus 3ax square minus 24a square x plus 28. As I said, leading coefficient is 1. So as x tends to infinity, f tends to infinity. As x tends to minus infinity, f tends to minus infinity. It's going from bottom to top. It's actually going from bottom to top. Correct? It's going from bottom to top. Now, how is it intersecting the x-axis? For that, we will have to compute the limit. Limit x tends to half tan of e to the power 2x minus 1 upon log x plus log 2. Right now, only you can do one thing. You can understand it's a 0 by 0 form. Correct? So, you can use your LH rule. d by dx of tan x is sec square e to the power 2x minus 1 into e to the power 2x minus 1 into 2 whole upon 1 by x. And this is limit x tends to half. Just see. As x tends to half, e to the power 0 is 1, 1 minus 1 is 0, sec 0 is 1. This is 1. e to the power 0 gives you 1. So you're left with 2x when x is half. That means 1. 1 is the answer. Or you can apply one more approach, bache, which I think many students are thinking also, which is the approach of standard limit. So you can say limit x tends to half. You can say tan of e to the power 2x minus 1 multiply and divide by the same argument. Here. Now again 2x minus 1. Here also 2x minus 1. And then below you have log x plus log 2. Now you know tan theta by theta as theta approaches 0 is 1. E to the power x minus 1 upon x as x approaches 0 again is 1. So you are left with 2x minus 1 upon log x plus log 2, and this much part is definitely 0 by 0. So differentiate 2 upon 1 by x, which gives you 2x corresponding to x equal to half. You get 1. So basically whatever approach you apply, either you apply LH rule right in the beginning or you apply standard limit, then you apply LH rule right in the end. Answer will come out to be the same, which is 1, and that answer is the value of A. My A has come out to be 1. I was searching for A, no, because now I can actually write my polynomial. It will be x cube, this is my f of x. X cube minus 3x square minus 24x plus 28. Please check. Please check. Now I want to know the behavior. I know it's going from bottom to top. That much I know. Let's compute f dash. This is 3x square minus 6x minus 24. 3 comes out common. X square minus 2x minus 12. Tell me. Not 12, 8. Tell me. X square minus 4x plus 2x minus 8. X minus 4 plus 2x minus 4. Alright, so you're getting 2 critical points. Minus 2 and 4, obviously plus minus plus, increasing, decreasing, increasing. This is how the setup of the graph is. At minus 2, it's point of maxima. At 4, it's point of minima. Also, this is not enough. Also, you have to compute f of minus 2 and you have to compute f of 4. Can you tell me what are you getting? Compute f of minus 2, you have the definition of f of x. No, compute f of minus 2. Minus 2 whole cube, minus 3 into minus 2 square, minus 24 into minus 2 plus 28. This will come out to be positive. Similarly, when you plug in x as 4, you compute f of 4. This will come out to be negative. So minus 2 is point of max. 4 is point of min. At minus 2 value of the function is positive. At 4 value of the function is negative. And the graph is going from bottom to top. That means obviously the graph is going to look like this. It will infinitely go down, infinitely go up as you are approaching to infinity and minus infinity. Here somewhere is minus 2. Here somewhere is 4. It is intersecting my x-axis at 3 distinct points. So it has 3 real and distinct roots. Please understand, before minus 2, it is increasing. And as you are approaching to minus infinity, it's also going to minus infinity. So it is going to go down infinitely. Between minus 2 and 4, it is again decreasing. So yes, it is decreasing. And after 4, it is infinitely increasing because as you are approaching to infinity, it's going up, 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 up. But because at minus 2 the value is positive, because at 4 it's negative, using the intermediate value theorem, at least once between minus 2 and 4 the graph will have to cut the x-axis once. At least once it will have to cut. At least once. But because between minus 2 and 4 the function is strictly decreasing, it will cut exactly once. Ideally at minus 2 if the function is positive, 4 the function is negative. So from going to positive to negative, it will have to cross the x-axis at least once. That's the intermediate value theorem. But because it's strictly decreasing between minus 2 and 4, it can't cut the x-axis more than once. So it's exactly once. That is why you can guarantee that there are going to be exactly 3 distinct real roots. Yes? Is this clear? Is this clear? Interesting question, right? This is actually matching our very first scenario, this one, this scenario. Yes, so the question the question right now in this session is not being discussed to just make you solve the question. That is never my idea. I don't want you to just solve the question. No. Especially for math, we can't just solve the question and get rid of it and run behind the number of questions that we've solved. We have to determine the quality with which we are proceeding ahead. The learning has to be enhanced with every question. The revision has to be polished with every question. With every question, new approaches, new ideas, new learnings have to be grasped. That is the idea. Okay, it's not about more number of questions, it's about the rich variety of questions that we have to cater to. I hope this is clear, everyone. Hashtag HTCC. Any confusion, any problem? Cool? Okay. I'll move ahead to this question now. Well, this question is giving me a bit of nostalgia. You know why? Why is this question giving me a bit of nostalgia? Because very recently I have uploaded a video on the Rankplus JEE English channel about finding the number of functions. And that was a video which talked about every complicated type of question you can get from number of functions. Be it number of functions from A to B or number of one functions, many one functions, onto functions, into functions, everything has been covered. If you watch that one video, it's a one-stop solution for all the questions which have been asked in JEE Main from number of functions. I've taken, I guess, 40-45 minutes to explain the entire core of number of functions, and this is one of the topics which is so much loved by NTA, but it is so much dreaded by students. So if you are someone who is not very comfortable with number of functions, please go watch that video. Okay, it will really be of big help. F is a function from A to B. Point is, A is this, B is this. A consists of 1, 2, 3, 4 and 5. B is A1, A2, A3, A4 and A5. Question says you have to create functions from A to B such that f of I is not equal to AI. That means 1 cannot get mapped to A1, 2 cannot get mapped to A2, 3 cannot get mapped to A3, 4 cannot get mapped to A4 and 5 cannot get mapped to A5. Okay, but you have to create mappings to create a function. What is a function? A function is a mapping between members of the domain with the members of the codomain in such a way that every member of the domain has a unique image in the codomain. Okay, every member of the domain has a unique image in the codomain. Now what this condition or the restriction is saying is that 1, you can't map with A1. 2, you can't map with A2, 3, not with A3, 4, not with A4, 5, not with A5. But it's not saying that 2 distinct members of the domain can't map and get the same image in the codomain. That is not being said. So it can happen that 1 gets mapped to A3, 2 also gets mapped to A3. That can happen. 4 gets mapped to A1, 5 also gets mapped to A1. That can also possibly happen. So only and only restriction is this. Keeping this in mind, please understand 1 has 4 choices. Yes or no? 1 can get mapped to either A2 or A3 or A4 or A5. It can't get mapped to A1. Similarly, bache, 2 also has 4 choices. No. 2 apart from A2 can get mapped to A1, A3, A4, A5. Yeah, even if the image gets repeated of 1 and 2, even if the image gets repeated, I don't care. That is not going to stop f from being a function, right? There is no restriction which says distinct members of the domain should get mapped to distinct members of the codomain. We are not computing 1-1 maps. We are computing functions. That's it. Similarly, 3 also has 4 choices. 4 also has 4 choices and 5 also has 4 choices. And even if all these numbers 1, 2, 3, 4, 5 get mapped, can they ever get mapped to a same number? If 1, 2, 3, 4, 5 get mapped to A4, let's say, it will violate the condition that 4 should not get mapped to A4. So all 5 can never ever get mapped to a single image. That part is covered here. So don't worry about it. Okay? Eventually your answer is 4 into 4 into 4 into 4 into 4. 1024. Such a baby question. Yeah? Yes or no? Very easy peasy lemon squeezy question. Yes? Yeah? Easy? As I'm saying, you do get complicated questions as well from number of functions, but all of them have been discussed in that one video. I will obviously be bringing those type of questions as well in the PYQ marathon, so that everything across the syllabus, whatever type of questions you can get from whatever topic, from whatever chapter, which are high probable and high weightage, they are discussed. I will be bringing, but looking at this question, it just reminded me that if you are curious, you can go ahead and solve that. Is that cool? Alrighty, let's go ahead. 1024 option C is the right answer here. Let's come to prob. Let's come to prob, probability. Events A and C are independent. Wow, they're independent. If the probabilities relating A, B and C are this, then talk about B and C, and the fourth option says A and C are equiprobable. That means their probabilities are same. Let's see. Can you try this out? A union C is given to you and A is given to you, but C's probability is not given to you. See, probability of A union C is given to you. Probability of A is given to you, but C is not given to you, and the question says A and C are independent. How do you exploit the fact that A and C are independent? Huh? Think hard. How do you exploit the fact that A and C are independent? Tell me. When you say probability of A intersection C, and you know A and C are independent, this is nothing but probability of A into probability of C. People, independent events is so common in JEE Main. I can't even stress upon this enough. I can't stress upon this enough. It's very common, very frequently asked. You must know the condition. Probability of intersection of two events is equal to product of their individual probabilities when they are independent events. Now see, A intersection C has 1 by 20. A has 1 by 5 into probability of C. So probability of C I have obtained is 1 by 4. Correct? Okay. Question says B and C. B and C are mutually exclusive, or B and C are neither independent nor mutually exclusive. First, let's see if they're independent or not. Probability of B intersection C. What is that? Oh, I don't know. Okay. Probability of B into probability of C. If they both have come out to be equal, then it will be independent. Otherwise, no. Probability of B is 1 by 6. Probability of C is 1 by 4. This is 1 by 24. This much is okay. But what is probability of B intersection C? I don't know. Till I don't know that, I can't comment upon option B and option C. Right? So let's start with probability of B union C. This is probability of B plus probability of C minus probability of B intersection C. Tell me, B union C has probability 3 by 8. B has 1 by 6. C I just found out it was 1 by 4. This I don't know. Let's see. So 3 by 8 is equals to 10 by 24 minus probability of B intersection C. This is 10 by 24 minus 3 by 8. One by 24. Did you understand? 1 by 24. That means B and C are independent events. 100%. They are independent events. But are they mutually exclusive? No, because the probability of their intersection is not equal to 0. The probability of their intersection is not equal to 0. It's 1 by 24. It's a positive number. That means B and C can occur together. It's not like they can't. They're not mutually exclusive. They're not mutually exclusive, but they are independent. So are they mutually exclusive? No. They are neither independent nor mutually exclusive. No. They are not mutually exclusive, but they are independent. A and C are equiprobable. A is 1 by 5, C is 1 by 4. No. B and C are independent. Yes, 100%. So probability is a chapter which again is something that scares a lot of students. I know that as a matter of fact. But again, probability is something from where you get easy questions also. So today I've kept a mixture. I've kept a mixture of different varieties of questions. You said you want mix and match from across the syllabus because that will give you a great testing platform to check whether you remember the formulas, the concepts, the ideas from the entire syllabus or not, from across algebra, calculus, vector, 3D. Of course, I'll be bringing more questions on vector 3D in the next class. But I wanted you to test your knowledge, your memory, your understanding, and the level of your preparation of your entire math syllabus as a whole. Okay, so take this session or any session which is going to come in this series very seriously, very seriously. Okay, cool. A is the right answer, B, C, D are wrong. Making sense, everyone? Hashtag HDCC here as well. Probability, I know it's not the strength of many students and I get constant texts that ma'am, probability is weak, can I leave it? I want to leave it completely. But the problem is don't leave anything completely. No, up questions like these though are very simple to crack. So at least go through the basics and trust me, I'm giving you a hack. This is something which generally teachers do not say, but I would like to say, if a chapter scares you to death, if a chapter scares you, like shit scares you, and you're like, I just can't see its notes, I can't see the Cengage books of this chapter, I just can't see the PYQs or any reference books for this chapter. No, it's just too overwhelming for me, it's too scary for me. If that's the situation, no, please start with NCERT. For example, probability is that chapter for you, pick up NCERT. Small book, very thin chapter. The volume of the chapter there, the number of pages for that chapter is very less. Pick up that chapter from NCERT, go through the solved examples, go through the exercise questions, easy doable questions, get that bump of confidence, that pump of confidence, get that from there. And then you will realize that, oh, now I'm in a better position to look at the PYQs, I'm in a better position to see the notes, I'm in a better position to attack questions. Okay, so not many teachers say this, but I will definitely, I would like to say that if a chapter scares you like highly, and it overwhelms you to even witness that chapter in any form or manner. If it's going on in my class, I will not go and attend it. If it's being discussed among the peer group, the study group, I will just not go and sit because it's kind of hitting me hard that I don't know this chapter, it's scary and I've not even studied it at all. If you're scared, like, like shit scared, it's overwhelming you, it's giving you stress and pressure and anxiety, please go open the NCERT. Sweet, simple, very comfortable and cozy book, which will give you that feel-good factor about the chapter. Okay, go through the chapter from there, look at the solved examples, solve some of the exercise questions, the answers are given at the back. You will get a grip on yourself corresponding to that chapter. It will no more make you anxious and you will get a clear idea about the basic understanding of that chapter very well. Okay, at max you should do that much. Don't leave a chapter completely. All right, making sense, everyone? I don't like my students getting scared, not at all. Okay, let's go. So this again is reminding me of a YT short. I had created a YT short again on the Rankplus JEE English channel. You can go and check out the short section. There I have discussed 7 results. 7 very important results which you have to remember very, very nicely. At the back of your hand, you have to remember. Very nicely to remember those results, and they are the soul of your binomial chapter, and the questions from binomial most often than not are asked from those results. For example, this question, look at this. What is summation k plus 1 whole square NCK? Now this is so easy only if you know those results. Otherwise you will keep messing up. See, it says summation NCK k plus 1 square. Open this up. NCK k square plus 1 plus 2k. Solve with me only. Solve with me. K going from 0 to n. K going from 0 to n. All right. So you can break the summation and distribute it. No, you will get what? NCK k square plus summation just NCK plus summation 2k into NCK. Perfect. Write it again properly. Summation NCK into k square. K going from 0 to n. summation n c k, k going from 0 to n, and twice 2 can come out, k into n c k, k going from 0 to n. You can write this as k square into n c k. That's a more familiar expression in which you remember. What is this? Can you tell me? Do you remember? Do you remember the results? Huh? Summation NCR, R going from 0 to n is what? NC0 plus NC1 plus NC2 plus NCN, which is nothing but 2 to the power n. Very famous, very promising result, asked tremendously from binomial in the paper. Next is summation RNCR. R going from 1 to n. 0 to n doesn't make sense because when r is 0, the term itself becomes 0. So saying summation from r 0 to n or 1 to n means the same thing. The sum will come out to be the same. What is this? N into 2 to the power n minus 1. Remember, I have derived it in my binomial session. Please go check out in the live section the binomial series part 2. One shot of binomial, but part 2. There I have derived all the results very nicely. Just go to that section where I've derived the properties and you will love it. You will fall in love. That's why I'm not proving it here. Please go check out the derivation there. And once you are very, very thorough with the derivation, how I've proved it, how have we arrived at this answer? First of all, it will cement that inside your memory because now you know the proof. Secondly, because the proof is very easy, even if you don't remember the direct result, you can in the paper also invest 15-20 seconds to derive that. It won't take much time. But you should first of all know what the derivation is. So please go check out in the live section of Rankplus JEE English channel, Binomial Theorem One Shot Part 2. Okay. What about summation R square NCR? N plus 1, 2 to the power n minus 2. I to remember it, but even when I was a student and I did not remember, I used to take 15-20 seconds to derive this. There is no shame at all. No shame at all. Better to get 10 questions right than to attempt 15 questions in which you have done negative marking in most of the questions. Because you've hurried, because you have wasted your time. Don't do that. Okay, I remember, but even when I was a student, I used to take 15-20 seconds to derive it. But for that, you should know the derivation. So this is n into n plus 1, 2 to the power n minus 2, plus this is 2 to the power n, and this is 2n 2 to the power n minus 1. So 2 to the power n minus 2 comes out common. You're left with n square plus n, 2 to the power n minus 2, right? Okay, so plus 2 square. This is n minus 1, 2 to the power n is there, no? And this is n. N minus 1 minus n plus 2, 2 to the power. When you will divide this by n minus 2, what will you get? 2 to the power n minus 1 minus n plus 2. So 2 minus 1 is 1 and 2 into 2 will give you 4. Please check. Yup. 2 to the power n minus 2, n square plus 5n plus 4. Yes, B is the right answer. Please check this. Check this out. Is this clear? This part, is this clear? Completely. I've just taken out 2 to the power n minus 2 common and accordingly I've simplified my expressions to get this answer sitting in option B. Again, bache, I'm emphasizing this question can become very easy. You can crack it in seconds if you remember these results. If you don't, this question can become equally lengthy for you. Number one, because you will be deriving the results. Number two, if even you don't know the derivations are very small, very cute and very easy. That's why I'm saying to go and look at the derivation. Literally, it's very easy and you will feel that I don't need to remember the results. I might as well invest 15 seconds to derive. It's okay. So if you don't know the results, you don't know the derivation, trouble. If you don't know the results, trouble. If you can remember them, great. If no, then at least remember the derivations. If both of them are absent, then such an easy question, which is literally a low-hanging fruit. It's a 1-minute question. It's a freebie. Freebies, you know freebies? Free K marks. These are like free K marks. Yeah, but only if you know these results. Only if you know these results. Let's go, people. Let's go and attack this question. This is fantastic. You will love this. You will love this. How many of you all know how to crack this question? See, it says S is the set of points where the function f is not differentiable. What is summation f of x where x comes from S? Okay. So, what all points S contains, I don't know right now. In order to find that out, I will have to examine my function f and actually check where all is it not differentiable. Correct? So, what is my f of x? Mod of 2 minus mod of x minus 3. But this question will challenge you and it will amaze you with respect to the volume of transformations that it contains. It will amaze you literally. And this question will help you revise all the transformations as well. Very good, people. You have nicely decoded that this question is going to be solved using the graphical approach. Please don't try to compute the critical points, then break the function into a piecewise function and then check the differentiability at the connecting points using the conventional method of left-hand derivative, right-hand derivative, and then matching them. Don't do all of that. If your visual apparatus is working fine, please plot the graph. If the knowledge on graphical transformations, transformation of function is absolutely clear to you, top-notch level, use the graphical approach. Okay, even if it's not, by this question it will be clear. Can we start? Can we start? How exactly are we going to draw the graph? Let me explain this to you. We are going to start with mod x, then we'll move to mod x minus 3. This is like you have f of x and you want to transform it to f of x minus a. What is the transformation? Can you tell me what is the transformation? Yes, it's horizontal shift. Horizontal shift. Horizontal shift along the x-axis to the right by 3 units. This is horizontal shift to the right of the x-axis by 3 units. This is the transformation of what? F of x goes to f of x minus a. So mod x goes to mod of x minus 3. I have taught this to you. This is the transformation being used here. Once you have come here, next you have to go to minus of mod x minus 3. Oh, what is this? What is this? How to come from g of x to minus of g of x? This means you just have to vertically flip the graph. You just have to vertically flip the graph about the x-axis. So this is your vertical flip transformation about the x-axis. Okay, so what has come into picture over here? Tell me. It's like g of x going to minus of g of x. This is what has come into picture over here. This is another transformation which is used called the vertical flip transformation. Moving ahead, after this, I want what? 2. Okay, so plus 2 minus mod of x minus 3. It's like I'm adding a 2. It's like this, no? I have the existing function, this, and I'm adding a 2 in it. It's like I have a function already, I'm adding a 2 in it. Adding a 2 in it means what? Yes, this means upward shift, or rather vertical shift along the y-axis, right? Upward by 2 units. Correct? So here what type of transformation has been used? H of x goes to h of x plus a, where a is something positive. This transformation has been used. This transformation has been used. The vertical shift transformation. The vertical shift transformation. Do we need anything else? Yes, we need a mod on the entire this function. We need a mod. We need a mod. So I need mod of this entirely, 2 minus mod of x minus 3. So when I have reached till here, after that I want the mod. After that I want to take the mod. When I have reached to a certain level, after that I want to take the mod. So this is nothing but the modular transformation. What does it say? Do you know that? We have used it in a question we've done a while ago. How do you transform? So here the transformation is f of x goes to mod of f of x. This is the modular transformation which we have to perform right in the end. Right in the end. what happens? It's f of x wherever f of x is non-negative, and it's minus of f of x wherever f of x is negative. So wherever f is above the x-axis, you keep it intact, undisturbed as it is. Wherever it's below, you take its mirror image and bring it above. You vertically flip it and bring it above the x-axis. That's how you perform the modular transformation. Okay, clear? So just imagine in this question, I have learned 1, 2, 3, 4. 4 different types of transformations. Horizontal shift, vertical flip, vertical shift, and modular transformation. This is how a rich question looks like. This is how content heavy questions look like. So in math, if I'm solving say 5 questions with you, it's equivalent to solving 15 questions with you. That's how voluminous the questions are. That's how much learning they contain. That's how much heavy they are. Okay? All right, let's get started then. Let's start with mod x. Alrighty, not a problem at all. This is my mod x. Okay. After this, I want to go to mod of x minus 3. So I will shift this graph to the right by 3 units. Let me change the color. I will shift this graph to the right by 3 units. Not a problem at all. This is 0, this is 3. And this is mod of x minus 3. Horizontal shift transformation has been performed. What is this value? 3 minus x is 0. That means x is 3. This is also 3. Baba, the part after 3 has definition x minus 3. The part before 3 has definition 3 minus x. 3 minus x, right? Yes or no? Yes or no? 3 minus x. Y equal to 3 minus x. When x is 0, y is 3, no? When x is 0, y is 3. So it's intersecting the y-axis at 3. Okay, this much is done. Next was vertical flip. Was it vertical flip? Yeah, now I have to perform vertical flip. Let me change the color. So I will be vertically flipping this. Vertically flipping this. Tell me, how will this happen? Like this. This is 3. This is minus 3. Basically, from top, you are vertically flipping the graph. So symmetrically, it will get flipped, right? Symmetrically, it will get flipped, and this is minus of mod x minus 3. Perfect. Now what? Now you have to vertically shift it above by 2 units. Okay, let's start very carefully. Vertically shift it above by 2 units. Pull it above by 2 units. Minus 3, when you push it to 2 units above, it will go to minus 1. Minus 3, when you push it above by 2 units, it will go to minus 1. And 3, this value, when you push it above, it will go to 2. Because at 3, the value is 0 here. At 3, the value is 0 here. When you push it above by 2 units, it will go to 3, 2. So you are basically going to get this. This is 3, this height is 2, and this value is minus 1. Yes or no? And this is 2 minus mod x minus 3. See, if I consider 2 minus x minus 3 equal to 0, you will get 2 minus x plus 3 is 0. So 5 minus x is 0, x is 5. This value is 5 and this value is 1. Very simple to just find out the intersection points. I am just doing it for more clarity, more accuracy. But this I have obtained. I have just shifted everything 2 units above. Now what you need is just mod. Just mod. So what will happen when you will take mod, bache? What will happen when you will take mod? Whatever is lying below will come above, but whatever is lying above will be kept intact. Please listen to me carefully. Listen to me very carefully. So this part is undisturbed. Yes, this is 1 and this is 5, and in between there is 3, the height is 2. Whatever part is above the x-axis, this part I have kept it as it is undisturbed. But the part which is below, I have to take its mirror image above and take its mirror image above. Can you see this white graph? Can you see this like a W? Very good. People have said W. It's like a W. Whatever is above, keep it as it is, and whatever is below, just take its mirror image. Flip it about the x-axis or take its mirror image about the x-axis, bring it above, because we're talking about mod. Mod means everything has to be above the x-axis. Everything has to be positive, non-negative. Correct? This is our final graph. This is my f of x, bache. This is my f of x. Can you tell me how many points of non-differentiability are there? As many as there are sharp turns in the graph. Yes, so we are not using the conventional approach of left-hand derivative, right-hand derivative. No, we are using the graphical approach and checking where all is the graph turning abruptly, What are the sharp-edged points being created? Because they are the points of non-differentiability. My function is throughout continuous, perfect, but it's not differentiable at 1, at 3, and at 5. So there are 3 points of non-differentiability. There are actually 3 points of non-differentiability, 1, 3, and 5. Easy, right? Interesting, isn't it? Had fun? Now I want summation f of x, where x comes from S. Okay? So S has 3 points, 1, 3, 5. That means I want f of 1 plus f of 3 plus f of 5. What is f of 1? Plug in here f of 1. 1 minus 3, 2 minus 2, 0. This is f of 1 is 0. What is f of 3? 3 minus 2, 3. This is 2. What is f of 5? Again, 0. What is f of 0? This is 1. What is f of 2? Again 1. What is f of 0? Again 1. That means 3 is your final answer. Very good, guys. Very, very good. Bang on correct. You people are literally on fire. Yeah, you're on fire. And I am so impressed. Trust me, I'm very impressed. Is this question clear, people? Volume of graphical transformations which was being used. Look at this page. This page, supremely important. This page, supremely important. So there were loads of learnings involved in the question. In a way, this question has taught you about transformations, isn't it? All these are just the transformations which you need, isn't it? Horizontal shift, vertical flip, horizontal flip, modular transformations. And f of mod x also you have seen in one of the questions before. So you know now. Now you know that, okay, this is what transformations is all about. So this is how a rich session, a voluminous, contentful session is created, wherein no matter how many questions we solve, but the volume of learning that you take is equivalent to 500 questions. Okay, and that is always my agenda. I don't go by the number always, but I always try and give you more than what I have promised. Always the delivery is going to be over my number specification. Okay, volume wise, quality wise. All right, look at this question. And this is mind-boggling. Mind-boggling, I would say tough in some sense, but interesting in even more sense. It's a very interesting question. Not a question which I would want you to pick up in the first go, in the first round, no. But definitely a question to attack, to practice. A mini version, a simpler version of this question can be asked in the paper for sure, but to be able to decode the concept behind this question is the major task. From a point P, tangents are drawn to this circle, and this circle. They are of equal lengths. If the equation of the circle through P, which touches this line at this point is this, then what is the value of A plus B plus C? So the latter part of the question is not important to me, because until and unless I don't have P with me, I can't actually do anything about the next part of the question. I am just concerned about the first part of the question, that from point P, I am drawing tangents of equal length to my 3 circles. Let's call this circle S equal to 0. Let's call this one S dash equal to 0. And let's call this one as double dash equal to 0. Is there something striking? Okay, I can see the comments. Is there something striking when you say tangents of equal length drawn to 2 circles, 3 circles? Anything striking? Think. Anything striking when you say tangents are drawn of equal length? What strikes? What strikes? Very quick. Tell me, no, what strikes? Huh? Cool. Some of you all are guessing. See, please understand, whenever this language comes, that from a point you are drawing tangents of equal lengths, this is clearly shouting out loud for the concept of radical axis. This comes at the end of the circles chapter. Many students get exhausted by the time they reach the end, and that is the thing of which JEE takes advantage of. It literally comes towards the end, students are exhausted, they leave this topic, somewhat they find it complicated to understand, they don't give it that much attention, that much importance, and they are not prepared thoroughly with radical axis. And the question on that is why it comes in the paper every time. And this type of a question is a do or die question. Basically, if you're able to do it, percentile up, not percentile down. So these are rank decider questions. Rank decider questions, because very few people are able to attempt it. Let's understand the concept first of all. Suppose you have two circles, okay, and this is a line. Understand the concept, please. I'm not talking about the question right now. Please understand the concept. I have two circles. This is a line and this has a speciality. The speciality is you pick up any point sitting on the line, and from there you draw tangents to these two circles. You draw tangents to these two circles. This point of tangency, let's say, is A. This point of tangency, let's say, is B. Then PA represents the length of tangent 1. PB represents the length of tangent 2. The speciality of this line is you pick up any point on this line and drop tangents to the two circles. The length of those tangents will be equal. You pick up any point from this line and you drop tangents to the two circles. The length of those tangents will be equal. That is the speciality of this line, any point sitting on this line. This line is what is called the radical axis for S and S dash. Radical axis of these two circles. And because it's a line, the equation has to be linear. Its equation is given by what? S minus S dash equal to 0. You would say, ma'am, this is the equation of the common chord. Yes, because when two circles are disjoint, this is how the radical axis look like. But when two circles are intersecting each other at two distinct points, the radical axis actually is nothing but the common chord only. Right? And in this case, so you know, the equation of radical axis will be same as the equation of common chord, which is S minus S dash equal to 0. So you can remember it in this situation that the equation is nothing new, because in one scenario, it actually becomes the common chord only. So S minus S dash equals 0, which you generally remember as the equation of common chord, is the equation of your radical axis. So please remember, the speciality of radical axis is that any point sitting on it is potential to give you equal length tangents to the two circles. P is acting like an external point. No. From an external point, you can draw two tangents. You're drawing it to the two available circles. The length is going to be equal. And that is why when it's said that from point P, tangents are drawn of equal lengths to the two circles, three circles, it immediately striked that, okay, the question is talking about radical axis. Now I think you know why it striked. Let's go to an advanced level. Suppose I have not two circles, I have three circles. Like in our current scenario, S equals 0, S dash equals 0, S double dash equals 0. Now see, this is the radical axis for the first two pair of circles. This is the radical axis for the second pair, and this is the radical axis for the third pair. So radical axis number 1 for this and this, these two circles. This is radical axis number 2, and this is radical axis number 3. Always remember, when you have three circles and corresponding to any two you are drawing the radical axis, you will have three radical axes, three lines, correct? All these three radical axes will always be concurrent. They are always concurrent, and the point at which they meet each other is what is called the radical center. Radical center is a point lying on the radical axis, all three radical axes. Basically, all three radical axes are going to be concurrent, intersecting each other at one single unique point, which is called the radical center. Now, speciality of this radical center is what? That this radical center is lying on first radical axis. That means from the radical center, I can draw tangents of two equal lengths to my circle S and S double dash. Because this radical center is lying on radical axis 2 also, from this radical center, I can draw tangents of equal lengths to these two circles also. And because my radical center is lying on radical axis 3, that means from this point, I can draw equal length tangents to these two circles also. So if the question said that from point P, you can draw tangents of equal length to all the three circles, this is only possible when that point is nothing but the radical center. This is the most important discovery, that P is nothing but the radical center, because from point P, you are not able to draw tangents of equal length to just two circles. You're able to draw tangents of equal lengths to three different circles. That can only happen when that P point is sitting on the radical axis, all the three radical axes. But if a point is sitting on all the three radical axes, that means it's nothing but the radical center only. So P here is the radical center, which is a fantastic discovery. I hope you understood. How have I come to this conclusion? The question did not say anything like that. It didn't say that it's talking about the concept of radical axis. It didn't say it's talking about P being the radical center, but that is true. That is 100% indeed true. So P over here, bache, is my radical center. And how do you plan to find it? Because until and unless you don't find P, you can't move to the next part of the question. So how do you find P? How do you find the radical center? Radical center. See, if three lines are concurrent intersecting at point P, P is the radical center, I don't need all the three equations of the radical axis of the three lines to give me my radical center. No, I can compute the equation of any two radical axes, intersect them, find the point of intersection, it will be P only. Because my third line will pass through that point only, which is the point of intersection of the previous two lines. So yes, you are correct. Consider finding any two equations of the radical axis, either 1 and 2 or 2 and 3 or 3 and 1 or 1 and 3, whatever. Any two you find and then solve them simultaneously to get the point of intersection. Whatever is the point of intersection of two radical axes, same will be the point of intersection of three radical axes. So let's start. Let's start now. S is what? X square plus y square plus x minus 3. S dash is what? Divide by 3. You will get x square plus y square minus 5 by 3x plus y. What is S double dash? Divide by 4. X square plus y square plus 2x plus 7 by 4y plus 9 by 4. Okay, if this much is clear, let's start. If I talk about S minus S dash, I will get one radical axis. If I talk about S minus S double dash, I will get another radical axis. If I talk about S dash minus S double dash, another radical axis, but I don't want a third radical axis. I want only two. So S minus S dash equal to 0 will give me radical axis. Number 1, let's say this is one radical axis. Okay, what will it be? X square minus X square 0, Y square minus Y square 0. You will get X common 1 plus 5 by 3 minus 3 minus y. Minus 3 minus y. So this is 8 by 3x. 8 by 3x minus y equal to 3. S minus S dash equal to 0. Please tell me. This is cool. This is your first radical axis, line 1. Now, S minus S double dash equal to 0. This will give me another radical axis. Okay. So, x square minus x square 0, y square minus y square 0, x common, 1 minus 2 is minus 1, minus 7 by 4y, minus 3 minus 9 by 4 is 0. So, minus x minus 7 by 4y, this is what? Minus common, 12 and 9 is 21 by 4. Please check this. Check this. This is minus x minus 7 by 4y equal to 21 by 4. This is your second radical axis. You can choose out of 3 any two. S dash, S double dash or S and S double dash, your choice. I have chosen S dash, subtracted, got one radical axis. S and S double dash, subtracted, got another radical axis. These two I will intersect. L1 intersection L2 will give me my point P, which is the radical center and which I am so desperately searching for. Can you tell me what are the coordinates of the radical center? Can you tell me what are the coordinates of the radical center? Please find it out. Very simple elimination method. Come on, come on, come on. Everybody, please. Everybody, I want everybody to calculate. Yes or no? Everybody try it out. When you apply your elimination method to compute L1 intersection L2, you will get P to be 0, minus 3. Please check this out. I'm not performing the elimination method now for you. I think you're too grown up for that. Yes, too grown up for that. Okay. Okay, cool. Now that P I have obtained, now I can successfully move on to the next part of my question. If the equation of the circle through P, through point P, which is 0, minus 3, touches a line L, which is x plus y equal to 5 at the point 6, minus 1, and the circle's equation is given to be x square plus y square plus ax plus by plus c is 0. What is the value of a plus b plus c? Does this diagram look familiar to you? Huh? Does this diagram look familiar to you? As long as you were reading the statement, it was like, oh my god, what is this saying? This is so complicated. But the moment you draw it, the moment you just keep reading and keep drawing, you have a circle passing through point P, touching a line at 6, minus 1. Its equation is given to you like this. Line is this. This is the figure which you come up with. Yes, absolutely correct, bache. Family of circles. I have explained this to you, right? I guess in the first or the second question, I don't remember. This same concept I have explained. This is so important. And this acts like a shortcut because you can see here the general equation is written which has 3 unknowns. I will compute the equation of the same circle but with just one unknown. What is that equation? The circle is going to look like x minus x1 whole square plus y minus y1 whole square plus lambda L. L is x plus y minus 5 is 0. So remember, this is x1, y1. And this is your L equal to 0. X plus y minus 5 is your L. X minus x1 whole square plus y minus y1 whole square plus lambda L equal to 0. Simplify. Quickly simplify. I want to convert it to this form so that I can compare and then fetch what is ABC. So x square plus y square plus 36 plus 1 minus 12x plus 2y plus lambda x plus lambda y minus 5 lambda is 0. Okay. So x square plus y square, this is what? Minus 12x plus lambda x. So x common, lambda minus 12, then 2y lambda y. So plus y common 2 plus lambda. Then this is 37 minus 5 lambda. Plus 37 minus 5 lambda is 0. Because my circle is passing through P, 0, minus 3 will satisfy this equation. 0, minus 3 will satisfy this equation. When x is 0, y is minus 3. This is 0, y is minus 3, 2 plus lambda plus 37 minus 5 lambda is 0. So 9 minus 6 minus 3 lambda plus 37 minus 5 lambda is 0. 9 minus 6 is 3. 3 plus 37, 40. 40 minus 8 lambda is 0. Lambda is nothing but 5. Is the entire flow clear? Everyone, tell me. Is this flow clear? I have computed my circle's equation. It had only one unknown, which is lambda. And I was confident I will be able to compute lambda because I knew an initial value condition which was given to me that my circle is passing through point P. That's why I found P in the first place. So that I can have lambda. The moment I have lambda, I will plug it back and I will get my actual equation of the circle, which is what? X square plus y square. Lambda is 5. 5 minus 12 is 7. Minus 7x. 5 plus 2, 7. Plus 7y. 37 minus 25 will give you plus 12. Both these are equations of the same circle. And hence you are in a position to compare now. Your A is minus 7. Your B is 7. Your C is 12. So A plus B is 0. C is 12. Your answer is 12. Enjoyed? Lengthy question? Yes. Brainstorming? Yes. Challenging the visual apparatus? Yes. Challenging the radical axis concept, which is considered to be so difficult by students? Yes. Fun to solve? Yes. Super duper yes. Will you do it in the first round? No. But should you miss out on the understanding of radical axis? No. You can get a simpler question than this. The only target for me to bring this question for you was that this is something which JEE Main keeps to test you on your knowledge at a high level. These are mainly rank determiners. These questions are mainly rank determiners, and Not all students are comfortable solving, but my students have to be comfortable with the idea because it's not that tough. It's not like it's super tough, no. It's just that you have never invested that time and energy and attention to decode it and absorb it and digest it. So this question was a voluminous question to explain you the relevance and the application of radical axis and radical center. So even if this much you understood, no, it's okay. That means you have a good idea of this topic. And now if any question comes, you can proceed in that 100%. Just remember, from the statement, I had figured out that this question is upon radical axis. From a point P, tangents are drawn of equal lengths to 3 circles. This language itself is actually the definition of radical axis, that from a point you're able to draw tangents of equal length to 2 circles. Right? So immediately that should strike you. That much knowledge you should have, that you can connect a question statement with a concept. That much knowledge you should have. Okay? Alrighty folks, so I'm going to wind up for now because I feel too many voluminous, rich and heavy questions have been shared with you and I don't want you to feel overwhelmed at all. So I'm going to give you right now in this live session, let me see. Yeah, I'm not going to give you in this live session any homework questions, but on my Telegram channel, which is, one second, yeah, which is Study with Bhoomika Ma'am, I'm going to be giving you around 8 to 10 homework questions to practice, and they are going to be continuation of whatever we've learned today. So somehow they will be demanding you to apply the same concepts that you've learned today, or there will be certain advanced level questions wherein you might face some trouble. So in the next session, I will be catching up on those questions as well and quickly revisiting them to help you with the homework questions. Wherever you have faced struggle, please let me know. Even on the Telegram group, you can let me know. And if I feel that there are some questions, couple of questions, 3 questions, 4 questions, or any questions where a lot of y'all are facing the struggle, then I will take it up in the live session as well. Okay, explaining it one more time to you in the live session, proper. Okay, but I will be giving you homework questions in the Telegram group. Make sure you join the Telegram group, Study with Bhoomika Ma'am. There only the PDF of this session will be shared, and there only you will get the homework questions which will complete your bunch of questions for today. And I will be coming up very soon next. This is just session 1 of the PYQ Marathon. Don't worry. 100 questions, 200 questions, 500 questions, 1000 questions, you will lose track of the number of questions. Those many questions I'm going to shoot at you. It's just that I want you to realize when it's math, it's not one question. One question is equivalent of 5 questions. So please treat it with that much respect, and I would sincerely recommend you to go through the session once more, see what all questions have we solved, what all approaches were discussed, in what all directions were you being asked to use your head, what all formulas, tricks, shortcuts, and slightly counterintuitive approaches were also discussed to crack a question. If a question was completely surprising to you, or if it brought in picture a surprising concept for you, please go through it again and digest it better. Okay, don't just leave it to, yeah, okay, I've solved all the questions, now I'm going to not look at it. No. I had already told you we are starting a PYQ Marathon series. You have to keep a separate notebook for this so that you can flip through the pages whenever you are free. It will keep on getting hammered and cemented in your system. That is what is the idea. Okay, not the question per se, but the concept, the approach, the formulas, the visualization, the graphs, everything. That's what matters. So on this note, it's me, Bhoomika, signing off. Do not forget the mantra, bache. Pain plus reflection is progress. If you have faced struggle in any question during this session, if you were not able to come up with the approach, you were not able to think how to solve it, you have studied a chapter, but while seeing the question, it's not striking you, it's okay. Don't be hard on yourself. Please don't be hard on yourself. Stop being a big critic in your life. To a certain extent, it's okay, but you should know pain plus reflection is progress. If you have found somewhere pain, reflect upon it, embrace it, reflect upon it, introspect upon it, and then learn from it and move ahead. That is the only way forward. So we have to learn in life to fail forward. Fail forward means we are learning from our mistakes, we are introspecting and reflecting upon our mistakes, we're literally accepting our mistakes and working upon them. That is how we are moving forward, because again, we are not committing the same mistakes. That's called failing forward. So in my class, you will learn how to properly and very beautifully fail forward, not fail backward. No. Not fail backward. Okay? So let me know in the comments below, how did you find today's class? Do not forget to hit the like button and also subscribe to the Rankplus JEE English channel ASAP. Okay? Thank you so much. Bye-bye. It's me, Bhoomika, signing